fly, even with a prepared presentation. So,
well, a bit of improvising is always pretty good, probably, in such things as this.
yeah, yeah, it's a little more than a little bit when I do it, but I'm working on it. I see how Levy does it and some of the other younger astronomers, and I'm like, I'm light years behind them.
Oh, I don't know
Unintended.
about that.
Um,
You're very good, Adrian.
Yeah.
yeah, it's I like I kind of like doing some things off the cuff, but I think a good mix of off the cuff and a little bit of a theme, and that way I don't go off the rails. I mean, I can go off the rails anytime. But having a little theme kind of keeps, it keeps it all within a certain standard deviation.
Yeah.
And I can let the standard deviation be wide, but keeping it there, I think, helps.
Sounds like a good policy.
I'm trying to stick with it. I also enjoy getting on. Although I'm getting on a little earlier tonight, but I enjoy sometimes being on at the same time as the Argentinians. It just almost feels like family. Of course, I couldn't be any further north from them, but I think we're at a similar latitude, but just in different hemispheres. So, their crux is probably about the same height in the sky as when I see the Big and Little Dipper. So it's an interesting symmetry there. Oh, and I appreciate the compliment on my presentations. I want to always acknowledge if someone says I'm doing well, I will acknowledge it. So thank
Absolutely. You. Yep. Keep on rocking.
Will do.
David, how are you tonight?
Oh, I'm fine, thank you, David.
It's good to see you
I really
again.
enjoyed your report. Wendy and I saw the 2003 eclipse from Antarctica.
Oh,
And the
wow.
highlight of it then was we got a 12-minute shadow bands.
Oh,
6
yeah,
minutes
yeah,
on either
and
side of totality.
And we saw shadow bands
That's
like
amazing.
never before, of course, on the ice. Yeah, it was incredible. Yeah.
Hmm.
I don't think you could even hypothetically imagine seeing them that well anywhere else. Forget the desert even, the ice was perfect for that.
Yeah, it was really very special. Did you see the launch of JWST?
Oh, yes. Everything is A-OK thus far. Keep fingers crossed.
I sent a note to Dr. Thomas Zerbucken, who one of the project managers. He gave a talk at one of my astronomy club's meetings, and I had to get his number because I basically helped get him into our Zoom call. So because I had his number, I sent him a message saying, "Congratulations, I know this must be great." His response was, "Thank you. Everything's going good so far, and Merry Christmas." So it was nice to be able to talk to someone directly who I knew had a huge hand in finally getting the JWST off the ground.
And who is near the top of the NASA administration too.
Yeah, that was but more important than that is the fact that the JWST did launch, and it does appear that the precautions they took were a very good idea.
Well, today they deployed one of the sides of this structure that holds one of the solar panels successfully. So, another step crossed. Okay, A-OK.
Yeah. Yeah, I don't mind the speed at which they're taking it. They only get one chance.
Right.
So,
if it doesn't unfold correctly, we're sunk. So
Right.
let's hope that we're all right here.
Yeah. I have high I don't want to say expectations, but it's looking like everything is going according to plan.
We should understand ultimately the first stars, galaxies, and black holes in the formation sequence of matter in the universe, if this works okay, which is big.
That's
Aside
huge.
from all the other things that it should do too.
I wonder how close we'll get to being able to have some serious discussions about the Big Bang. I don't know how close JWST can get to identifying, anything like that. And my very limited knowledge of the exact theory of how the Big Bang worked. Would JWST be able to come close to seeing that?
Well, I think that cosmologists would argue that the evidence for the Big Bang is already overwhelmingly established
Pretty overwhelming
in multiple ways, but we should see the first luminous matter that formed, which we can't now. We're several 100 million years after the formation of the first stars, planets, and galaxies with Hubbell and other instruments. So that should show us, how did the first stuff in the universe form? When the universe cooled, nobody knows yet. That's big.
Right. I know that's going to be exciting to have. Basically, I think the word is interpolated, but I could be wrong, and then drawn up so as to give kind of a image to go along with the data that JWST gets. So another question is, do you know, or does anyone know how long Hubbell will go in order to, say, combine Hubbell and JWST data on some of these observations that we'll be able to do?
No, but it's already outlived its planned lifetime, and according to those who ought to know, if they're being completely forthright, which they probably are, it's going to last a little while, a few years more. So there should be some overlap there. And of course, the wavelength coverage is different, of the two telescopes, but it will be useful to have simultaneous observations of some things.
Yeah, looking forward to seeing if they if there'll be some time given to where both instruments can see the same object. I'd love to see if they're able to get any detail on some of the more distant galaxies that Hubble's been able to detect, and turn them from blobs into something with a little more structure. That'd be cool.
That's certainly one of the main science objectives here for Webb, is to look at and understand nobody knows whether galaxies formed first and then black holes in their centers and stars turned on within them. Did stars form first and then accrete into galaxy? Did black hole seeds form first around which luminous galaxies form? Nobody knows yet. So we should solve that riddle, which is a big piece of the cosmological puzzle. We'll see.
All these questions coming in. Will globular clusters be a part of that discussion?
Oh yeah. Yep.
Is that their formation? I know there's there's theories surrounding that maybe those clusters were at once dwarf galaxies and that's all that's left, or they simply formed on their own.
And I think it's thought to be some of each. Omega Centauri is agreed upon by everyone now to be the defunct nucleus of a dwarf galaxy, but it's enormous for a globular cluster. But it's clearly globular cluster, the stars in them are 10 or 11 billion years old. They formed before the disks of normal galaxies built up, which is pretty amazing.
Yeah. No, that always got my attention. As
mighty Delta IV heavy rocket.
I think we're starting, so I'm going to go ahead and go on mute. Thanks, Scott.
NASA launched
thanks,
Parker
David.
Solar Probe to touch the sun. After spending a few years spiraling closer to our star, the spacecraft has finally arrived.
It's amazing. Parker Solar Probe is touching the sun. And
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
this is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the sun? To answer that, we need to look at the sun's structure. Unlike Earth, the sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the sun and gushes out into space as solar wind. The boundary that marks the edge of the sun's atmosphere is known as the Alfvén critical surface. We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the sun's atmosphere during eclipses because it's important for understanding how a star influences life in the solar system. But much about the corona remains a mystery.
Two of the most challenging scientific mysteries in astrophysics occur in a region that we call solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere, the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the sun, the spacecraft was around 20 solar radii, or 8 million miles from the sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took these images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. Here we see distinct cells. As heat rises beneath, these convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life. So understanding it is critical as we search for life beyond our solar system.
That will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.
Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and you are watching the 78th Global Star Party with the theme of the amazing life of stars. That video from the Parker Solar Probe team is amazing. And I can't say that all stars behave like the sun, but we are learning a ton about what goes on inside of our star and the energy and all the dynamic processes that happen there. So it's starting to help unlock some of the secrets of stars as we apply that knowledge towards the distant ones that we look at with telescopes. Earlier in the program, if you had been listening, you would have heard Dave Eicher talking to Adrian Bradley about his experience in Antarctica with the eclipse and some conversation about the James Webb Space Telescope that we saw launch on Christmas Day. We have a great program lined up for you, but like on every Global Star Party, we started with our dear friend, Dr. David H. Levy, who entrances us with poetry, wisdom, and getting the feel of each Global Star Party. So David, I'm going to turn this over to you. Thanks for coming on for the 78th event. And, it's amazing that you're here every time.
Thank you, Scott Roberts, and welcome to the 78th Global Star Party. We've had a lot going on. David has told us about the total eclipse in Antarctica that he just witnessed, and I think most of us saw the launching of the James Webb Space Telescope. But tonight's Global Star Party has to do with the lives of stars, and that reminds me of a very apocryphal story that took place after the 1919 solar eclipse, in which the general theory of relativity was proven by Arthur Stanley Eddington, and the light coming from being bent as it goes around the sun. Mm-hmm. And that's not I wasn't born yet. I was far away from being born. But my dad and my mom would have been 1 year away from being born. Dad would have been around 8 years old at the time, and he might have read about that. Anyway, it's kind of interesting as we think about in this Christmas season, all the things that are happening. And the thing that I was thinking about as we were watching James Webb and its flawless launch the other day was a quotation that we heard on Christmas Eve of 1968, 56 years ago. And I would like to share that with you right now. We were all watching, our whole family was sitting in my parents' room watching their little black and white TV set. And they had the program with the little banner at the bottom that says, "Live from the Moon." And it was really so unforgettable to watch and listen to the astronauts in Apollo 8 read the following quotation. And they actually took turns, all three of them. And here's how it went. "We are now approaching lunar sunrise. And for all the people back on Earth, the crew of Apollo 8 has a message that we would like to send to you. In the beginning, God created the heaven and the earth. Now the earth was unformed and void, and darkness was upon the face of the deep, and the Spirit of God was over the face of the waters. And God said, 'Let there be light,' and there was light. And God saw the light that it was good, and God separated the light from the darkness. And God called the light day, and the darkness he called night. And it was evening, and there was morning, the first day. And God said, 'Let there be a division in the midst of the waters, and let it divide the waters from the waters.' And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so. And God called the firmament heaven. And there was evening, and there was morning, on the second day. And God said, 'Let the waters under the heaven be gathered together into one place, and let dry land appear. And it was so. And God called the dry land earth, and the gathering together of the waters called he seas. And God saw that it was good. And God said, let the earth put forth grass, herb yielding, and fruit tree bearing fruit after its kind. And there was evening and there was morning on the third day. And from the crew of Apollo 8, we close with this: good night, good luck, a Merry Christmas, and God bless all of you on the good earth. And I think all of us remember, with everything that went wrong in the year 1968, the Time magazine chose to make those three astronauts the people of the year. And before I give it back to Scotty, I'd like to introduce Dina, who is here from the Denver Astronomical Society. And Dina and I have started the Junior Astronomical League. And we're going to have our next meeting this coming Sunday afternoon, I believe. And Dina, if you would like to say a few words, I would appreciate that.
Hi, David. Thank you very much. It's a pleasure to be here again. And I am certainly looking forward to having you and some of the other folks here at yet another meeting of the junior astronomers here in Denver. We hopefully will have more of the local kids on and more from around the continent and maybe around a few continents join us. So I'm looking forward to that and seeing what these young folks come up with, what they want to work on and where they want to take this. Just today I spoke with a young man who's a member who just graduated from Colorado School of Mines, and he's going to be a speaker at one of our upcoming meetings. And what he's been up to was really exciting, and I'm thrilled. So thank you for helping us launch this and being a part of it.
If any of you are interested, thanks, Dina. If any of you are interested, if you could send a chat message to Scott, he will then arrange to send you the link when the link is available for Sunday afternoon's meeting. And I hope that a lot of you here, especially the young people, will be able to join. This was a worldwide effort. We have the Royal Astronomical Society of Canada involved in it, and other groups around the world. And it's going to be very simple. And as Dina says, eventually we think that the young people are going to handle the entire effort themselves. And thanks very much to all of you on the good earth. And now back to you, Scott.
That's great. Thank you. Yeah, David, I do remember watching that on television, and all of the Apollo program. Kids from the 60s had quite a treat. And it was almost, I think we were almost all in borderline disbelief, believing on one side that we could do anything, okay, but on the other side that we were going to the moon at such a quick pace, that it almost started to feel normal, and of course we later in our lives realized how unbelievable and remarkable the whole scenario really was. So, but go ahead, Dan.
Things that we've seen in the last years of our lifetime, my lifetime, I have to say that the launch of the Webb telescope is one of the highlights, but not Absolutely. The launch. The launch was great, but I've seen lots of launches. So a lot on TV, some in person. But what really made this one special turned out to be a little speech given by the NASA administrator. And at the end of it, and he's a government employee giving a speech, what do you expect? And he's going through talking about the people that were involved. And as near the end of his little speech, he said, and there was a little shepherd, a small shepherd boy in the Middle East who looked up at the stars and then wrote a poem about it. The heavens declare the glory of God. That little shepherd boy became king of Israel eventually. And that really struck me to the core. I thought that was wonderful. And I just wanted to mention that.
Thank you, David. Thank you. Well, it's great. Well, As I mentioned earlier, we had been talking kind of behind the scenes with Dave Eicher, and he was relaying some of his experiences in Antarctica, which he's recently back from, and also his thoughts on Jay West, which have us all very excited. I can say I was on pins and needles the whole time, and I probably will be somewhat that way until I know that they've completely unfurled everything and they've turned everything on, and that it's really, doing the science it was born to do. So because we're going to see some amazing stuff. But this week, after a bit of a hiatus, Dave Eicher is rejoining Global Star Party and turning his sights on something a little bit more earthly, which is the minerals and gems out of his amazing collection. In case you guys don't know it, Dave Eicher is the editor-in-chief of Astronomy magazine, but he has devoted his life to writing and popularizing astronomy. He's known throughout the world for the amazing work that he does, his books, his lectures, his inspiration. And it's amazing that we have Dave Eicher here back to back with David Levy. So David, I'm going to turn this over to you.
Thank you so much, Scott. And I'm almost thawed out now. And I think maybe I'll talk a little bit next week about Antarctica. And we did see the eclipse. We were lucky enough to see a brief eclipse down there on the ice. So maybe I'll talk about that a bit. I apologize for my absence, but there was no Wi-Fi at Union Glacier Camp in the middle of nowhere. So I tried, but now I'm back for better or worse. So let me share my screen. I'm going to talk tonight about a little bit more on the mineralogy, and I promised to give you a part 2 on a favorite mineral back when we left off couple moons ago. Favorite mineral of mine, fluorite, which comes in. This is not fluorite here. This is a tanzanite crystal, the placeholder there, but fluorite is one of these minerals. It's cubic mostly. It comes in basically all colors of the spectrum. It's easy to collect. It's inexpensive, many of the specimens. So it's a good one for people who are starting out in, this is really planetary science, studying minerals. This is how the universe makes pure substances, combining these atoms, if you will. So let's just review very quickly what we're talking about here with a little bit of mineralogy, a little bit of planetary science. I believe in a divinely ordered universe, said Thomas Jefferson, one of the heroes of American history in some ways to some of us. Isaac Newton, another hero of ours, said, truth is ever to be found in the simplicity, not in the multiplicity and confusion of things. And this is underscoring how the universe is ordered, and it exists in an ordered way because of the principles of physics, not by any supernaturalism. Minerals demonstrate this. Their atoms are assembled in precise ways because they're attracted electrochemically. They don't just magically form in the ways that they form. There's a reason for it, and we understand that, chemistry and physics now. The inherent properties of the atoms that make them up guide them into assembling in a specific, what mineralogists call a crystal lattice, which for fluorite, usually, although there are modifications, usually for fluorite, it's a very simple one, a cubic crystal assembly. So fluorite part 2, as I mentioned before, it's calcium fluoride, CaF2. Fluorine, when it's a gas, is extremely dangerous and toxic, but when it's locked up in a solid like this, it's inert and it's safe to play with. And as long as you don't take minerals and grind them up and put them on your breakfast cereal, many minerals are relatively safe to handle, as is fluorite. It comes, as I mentioned, in a huge range of colors: purple, lilac, yellow, green, colorless, blue, pink, etc., etc. It's a primary gangue mineral, which means it's a sort of a secondary mineral, if you will, in hydrothermal veins. very hot fluids that contain calcium and fluorine atoms that are flowing together and crystallizing at the right temperature and over the right time intervals. It was named in 1797 by an Italian mineralogist, Carlo Nepione, for the Latin fluor, to flow, because it was used from very early on in history as a flux, as an aid in smelting iron to control the viscosity, if you will, the thickness of the iron flow. It's a member, of course, of the fluorite group. There are other minerals in its group, and there are many, many, many unbelievably large number of great localities where it comes from. Mineralogists are always very interested not only in the minerals, but in the precise spots where they come from, because that's important in understanding how they formed and the relationship from specimen to specimen. So they get down to not only, you know, states and countries and counties and regions and so on, but sometimes even actually specific areas within a specific mine to study where things came from individually. So we looked at this again a few weeks ago when I was with you last time. This is the crystal structure of fluorite in a simple diagram. It's isometric, which is a fancy pants word for cubic. And as I mentioned, it consists, as you can see, of calcium and fluorine atoms. Well, and now let me just give you, so this is part 2. I showed some of these already last time, but I'll just show a few more examples. There's so many, and I've been shamed by other mineral collectors that of 1,500 minerals, they think that, you know, 1,400 of them in my collection are fluorite. That's not exactly true, but I do have a lot of fluorite. So I have a part 2 of showing some nice examples of what some of these things look like. And as I mentioned before, if you want to get into mineral collecting, which is a kind of a partner hobby with meteorite collecting, a step closer even to astronomy, if you will. In the old days, you could go and collect these things yourself. In my father's time, now, you know, for about the last 75 years or a little more, there are enough lawyers in the United States, in the world, that they don't want people falling down shafts and getting lost and so on. So you really have to collect these minerals at mineral shows where dealers bring them. But fluorite is a really inexpensive and a really pretty mineral. So you can have specimens of these for relatively low cost. This is from a famous mine from Derbyshire, England. This kind of honey-colored example here. There are not too many fantastic minerals from my home state, my native state of Ohio, but this is one of the localities, a fluorite with a mineral, it's the white mineral called celestine, that comes from northern Ohio, from Clay Center, Ohio. And this is a very unusual honey, or it's often called root beer colored fluorite, which comes from this. That's the best examples of this color come from northern Ohio here. There are examples of very bright and vivid blue, and all of the colors in most all minerals and in fluorite certainly here come from very small amounts of impurities that are locked up in the crystal lattice, the crystal structure. So there are different chemicals, a smaller number of atoms that are in there as impurities that color the minerals differently. This is a nice vivid blue fluorite from China, from relatively recent finds. Here's another blue from a very famous fluorite district. That's an area in Kentucky and Illinois that has a huge variety of fluorite and a lot of calcite, and this area where there are lots of caves and so on. That's a very rich area for forming minerals like fluorite. And so here's this pale blue from the so-called cave in rock district, which is well known to mineral collectors. Here's another English example with this sort of honey yellowish color of fluorite. And we have a variety of places. One of them, the more recent finds from Pakistan, of a pinkish fluorite. This shows this is probably manganese atoms that are coloring it pinkish or reddish. And here is another vivid blue Chinese fluoride on a big quartz crystal here. You can see the modified, these are not cubes really, but you can see even some dodecahedrons there. Of their various modifications and twinnings and so on of how the crystal builds up depending on how it grows and how much material is available that can be contributed to the crystals as well. Here's a German example of a fluoride, another yellowish one with little, that's speckled with some little quartz crystals on top. And here's a very famous Colorado Western mine that's a silver and gold mine called the Camp Bird Mine near Ouray, Colorado, very famous American mine. And this is a piece of fluorite that's sort of a sea green color, where most of the famous stuff that came out of the Camp Bird Mine was gold and silver. The Swiss Alps and Italian Alps are very famous for very nicely formed crystals of fluorite with a very deep pink or sort of a dull red color. This is one of them, and you can see a nice octahedron there on the left that's the largest crystal. These are fairly rare and valued by collectors. Here's another sort of, this doesn't show the blue quite as vividly as it is, but it's a sort of a sea green, blue-green here in a famous French locality here that's called the Le Bourg mine. And here we're back to the cave in rock district in the United States here. And here you can see an example of what mineralogists call zoning on the edges of this is a big fluorite crystal that's almost as big as your palm. And you can see that the chemistry of the crystal as it finished building up changed from the impurities in it, from that deep yellowish color to sort of a light sky blue on the edges there. So the chemical makeup of crystals even can change as they crystallize. Here's a somewhat more recent find that's coming out of the Middle East. This is an Iranian fluoride, and again you can see a little zoning of purple color around these crystals of fluorite. Here's back to the Alps here. Here's another example of smaller crystals in an alpine matrix rock here of this vivid pink color of fluorite from Italy, the Italian side of the Alps here. And here is a famous Russian locality that produces all kinds of fluorite. And you can see these very modified cubes here that are dodecahedrons and other shapes, other geometric shapes from a famous example of lots and lots of fluorite that comes from Eastern Russia. And that's it. Those are the examples I had today. And because Scott always encourages me to, I'm going to do a shameless bit of self-promotion here momentarily as well, and say that my partner and one of my partners in crime and in doing some writing, Michael Bakich, and I have a kids book about space that's coming out late this coming year here from Black Dog and Leventhal. It's called A Child's Introduction to Space Exploration. That is all about space. So I'll talk a little bit maybe more about that in a few months, but that's the latest book venture. And that's all I have tonight, Scott. So thank you. And maybe next week I'll go back to the frozen wilderness of Antarctica.
Wilderness, okay. Well, something else I would like to talk about is Comet Leonard. I would imagine that Astronomy Magazine is getting tons of really wonderful images of Comet Leonard at this point.
We are getting deluged, yes. And of course, the tail is in a dark sky is really, really long and sort of kinky. You can see, solar wind effects in the tail now, and the coma is nicely detailed now, and maybe David can comment on this, being a comet expert as well a bit. But this is as nice a comet as we've had, of course, in a long, long time now. And so being discombobulated, getting back from, the trip and living in Milwaukee, which means that it's cloudy here about 90% of the time. I haven't seen it in the last few nights, but I hope to again soon. It's a beautiful comet, though, the images that are being produced.
That's very cool. And the other thing I'd like to point out, I read an article can't remember exactly where, but November of this year, it was announced for the first time that they detected an element found in our bodies, which was fluorine in a galaxy 12 billion light years away. So this galaxy is called NGP, not NGC, but NGP 190387, and they have determined that fluorine hydrogen gas or whatever was coming from Wolf-Rayet stars. Okay, Wolf-Rayet stars are very rare stars. So when these stars explode and release the stuff that they fused inside of their cores, one of these is fluorine, and so this is something. This is a Starlink of the natural kind. Okay. That we have with the universe,
Exactly. Exactly. That's very exciting. And if you're French, Wolf-Rayet stars are massive stars that are far down the road in their stellar evolution, and they've been stripped of their atmospheres. So they're intensely hot. They're radiating the hell, if you will, out of the surrounding nearby interstellar medium. And that's why we get a lot of nebulae that are around Wolf-Rayet stars. And so these exotic elements are out there sort of pushed into the nearby interstellar medium as well. We know, of course, ever since 1862, the fortunate invention of spectroscopy by Bunsen and Kirchhoff and others, that the chemistry of the universe is uniform everywhere we look. So we know that all these elements, more than 100 elements that exist in the periodic table, many of which are in our bodies, even some toxic elements if there are too much of them. And that we're also radioactive slightly in our bodies, so we have a little bit of stuff that's dangerous in us, but all these elements are out there in the universe, and it's exciting because fluorine in a distant galaxy is a somewhat exotic element, but there are much more exotic compounds that we've seen, of course, outside of Earth. As we've talked about before, and forgive me if I've said this too recently, Scott, but the first cometary material that was returned to Earth in 2006 from the Stardust mission, Comet Wilt 2, had glycine in it. Now that's the simplest amino acid. So the building blocks of proteins, if you will, the stuff of life is out there in our distant solar system, far away from Earth. So this again is very suggestive, as Carl Sagan always used to like to say, that the building blocks of life are ubiquitous through the universe. And it would be absurd to imagine, we've gone through the entire history of the last 2,000 years scientifically finding out how not special Earth is. So there could be a whole lot of life out there. The problem is,
turn out that life as special as it is not just special to us.
Well, it's incredible that we can be alive and made of atoms and talk to each other and think about the universe, but we may not be so special that we're unique, that we're the only living beings anywhere. That would be pretty remarkable, given that there are 100 billion galaxies and a couple of 100 billion stars in every galaxy, but the distance scale is so huge that we need to take care of each other here, because it's a long hike to the next civilization, certainly. Yeah.
No one's gonna swoop in and save us, I don't think. So
it takes you longer to get to the next civilization than it does to get to Antarctica, even.
That's right. So that should be a lesson to everyone out there. Be responsible, okay? Do your best out there.
But that's thanks for bringing up that exciting finding, Scott.
Yeah, I was really impressed by that. I'm always looking for those kinds of connections because, we always say, astronomers always say that we're made of star stuff, but how exactly are we made of star stuff, and where does it really come from?
We're
So
literally, and again, forgive me, I don't want, sorry for babbling on. I've been maybe saving this up for 3 weeks, but we literally are made of the atoms in our bodies were created, the heavier ones in supernovae and exploding massive stars, or dead massive star, or colliding neutron stars, or the deaths of lower mass stars. So literally the same atoms are recycled into us. We're literally made of the stuff of the stars.
That's awesome.
It's not hyperbole.
Right. Yeah, that's right. But still, science is trying to figure out how these things fuse, and it's miraculous that we've figured out as much as we have.
And
but
we
still, just as miraculous to know just how much we really don't know, So.
And we're just starting out another chapter now in learning a bit more with Webb. So let's keep our fingers crossed for another month to deploy this thing, basically.
Right. David, thanks again for coming on.
Thank you.
Well, up next is Terry Mann. Terry Mann is the secretary of the Astronomical League, but she is a force within the Astronomical League and a force in amateur astronomy herself, and she has been for a long time. She is an adventurer. She travels all over North America to seek out the Aurora Borealis, to see nature in all of its splendor. And, I'm always constantly in awe of what Terry has done as far as her courage and her knowledge of being out there. So from time to time, she shares some of that, some of her experiences with us. But and she might tonight, you just never know. But she is with us from the Astronomical League that we so much appreciate. And I like to point out that the Astronomical League is, if not the most important, one of the most important astronomy organizations in the world. They are a federation of over 300 clubs. They have in the neighborhood of 20,000 members, and they're growing. And they take care of their members. It's very inexpensive to join. You can either do that through a member club or as a member at large. And you can get involved in their observing programs, in their award programs. They have really supported our community in ways that it's hard to express. And it's largely an all volunteer group. So, and I'm sure Terry can relate to you how much she has volunteered over all these years. But I'm glad she's here with us tonight. And so she will start the door prize program, part of our show. And so, Terry, it's all for you.
Well, thank you, Scott. It is a pleasure to be here. It's been a while since I have been here. Actually, I just got back from Death Valley, and I have never been at Death Valley, and I had the best time. I want to go back there. I spent the night at the racetrack imaging, and it was spectacular. It was just one of the best trips I think I've ever taken. So, and I'm sure a lot of you, Dave, I'm sure you've been there.
This is not a racetrack with cars, right? I mean,
I'm sorry. Yes, the moving rocks. Yeah, the rocks that race. But yeah, Death Valley, I could not believe how dark the skies were. I mean, it was incredible. And I've already said I'm going back next year. I think that's going to be one of my favorite places to go. So
absolutely.
Yeah, definitely a lot of fun. So I am going to go ahead and share my screen and ask the questions for this week. As you know, we always start off with our solar slide. Make sure that if you ever look at the sun, you have the proper filters to do this, and those can be bought at a variety of places. Do not think sunglasses are strong enough. I really had some people say, if I wear 2 pairs of sunglasses, is that just as good as a solar filter? And no, it's not. You really have to think about what you're looking at when you look at the sun, because it will damage your eyes in a blink of an eye. So always be careful when you're first learning about the sun and you want to look at it. Make sure you have the proper filters. And so what I want to start with is the answers from December 21st. The first question was, a star with the following designation is famous for being what? That is the designation for the Southern Pole Star. Second question was, Fred Hoyle was famous for naming something that he opposed. What was it? Well, that was a Big Bang. Hoyle was a steady state theorist and diversively used the term Big Bang on the BBC radio show.
That's called instant karma.
Yeah, definitely. The last question was, the largest storm ever observed in the solar system occurred where? Well, it occurred on Saturn, Saturn's great white spot of 2010 to 2011. And these are all the names of the people that answered the questions correctly, and their names will be added to a list. And at the first Global Star Party of every month, we announce 3 winners that are chosen by random. And so the questions for tonight, please send your answers to secretary@astroleague.org. First question will be a true or false. There are more trees on Earth than stars in the Milky Way. Is that true or false? Second question, the new general catalog was assembled in what year? And again, please send your answers to secretary@astroleague.org. The last questions. About 12,000 years from now, we will have a new North Star. What is the name of that star? And lastly, we have our next Astronomical League Live coming up on January 21st at 7 p.m. Eastern Standard Time. Please stay tuned. We will have more information about that coming up. And Scott, I think that will do it for me.
Okay, well, thank you very much, Jerry. So
Thank you, Scott.
I look forward to seeing some of those images from Death Valley. That'll be really
I'm
cool.
working on them now.
Okay.
Thank you.
Wonderful. Wonderful. Okay, well, up next is a gentleman who always wows us with his nightscape photography and his descriptions of the landscapes and the nightscapes that adorn them. And so Adrian Bradley, you've got the stage.
All right.
Thanks for joining us again for Global Star Party.
Not a problem. Can everyone hear me?
Yes, and we can see you
Okay,
too.
good. I made the successful switch from cell phone to computer behind the scenes so that I could find some images to share. When I talked about what I wanted to share tonight, I talked to Scott and I said, well, I've got some interesting Cygnus region pictures. The theme is stars, and the starlight that I usually like to capture turns out to be Milky Way photography. Any nightscape photography will do for me, just trying to put Earth in the picture. And I know, Terry, I've seen some of your work, and you've got some of your work behind you with the star trails. I'm chasing your amazing work. So I hope to share the image of Skies Up magazine. I can do a plug for you, Scott. Read Skies Up magazine from Explorer Scientific, especially this month.
Especially the cover.
Especially the cover. I will, I just gathered some images, so I will go ahead and share my screen.
All right.
Read Skies Up magazine. I'll try and find the cover of that magazine.
Here, I'll give a link.
Okay.
So find it.
Yep. And so, in fact, we'll get that out of the way. So this is not the Cygnus region, but it will be a very familiar looking image if
Absolutely.
you look at the cover of Skies Up magazine. And it was one of the better images of the Orion region. This goes along with a lot of Milky Way photography that I would see as I was learning how to do it and getting interested in it. I would see a lot of Milky Way photography of the good old, the good old core, and a lot of Milky Way chasers prefer to shoot at the core. And there's good reason for that because it's bright and it's a beautiful thing. Here's an example of what everyone tends to shoot at. It's this core region. And if you're in the southern hemisphere, you see the other side. We see the northern galactic bulge, and you see in the southern hemisphere, you see more of the you see the southern side with the jewels that are there. What I wanted to do was highlight that you don't have to stop shooting the Milky Way. Yes, it's colder and you have to bundle up, but there can be beauty in the Cygnus region. And so some of the images that I've been able to shoot, excuse me, even if you shoot something like this, which is sort of a fuzzy band, most of the time in the winter, the months of November, December, you're looking straight up. You're shooting at the summer triangle as it recedes, and it's a very busy place, and it's worth turning your cameras to. Now, this is more of the Cassiopeia region here, and I'm realizing because I see the double cluster, the heart and soul, and Andromeda. Cygnus comes above it. Let's get an actual, here's an image. The Cygnus region is marked by Cygnus, which there's Satyr, there's Deneb, there are the stars here, and Alberio is sort of hidden down above the trees. There's me. And most exposures will show the North American Nebula, and if you expose long enough, the Pelican Nebula. So, and then get out the book and get this nebula too. It's a part of a very busy Cygnus region. I've attempted to image this, and you can see this, although this looks more like a painting, the North American Nebula shows up, the Pelican shows up right here. Here we are. This is when the Milky Way is rising, and at about 41 north latitude, this part of the region becomes parallel to the ground as it's coming out. And compared to the Cassiopeia region, it's a brighter part of the Milky Way. Here we are again with one of the many lighthouses in Michigan, Point O'Bark Lighthouse, with a whole lot of light, shooting with a lot of light going. This isn't even that bad. The lighthouse light shoots outward, and when you're there, it seems a lot fainter than it really is, and it's shooting straight out, to the ships at sea. They recently added these big bright yellow lights, and I had to play around in post to get rid of them. But there you are, North American Pelican, barely, and this nebula here, which I will have the name of by next star party, because now I have to look up this region. But those are the nebula that I look for when shooting the Cygnus region. Once again, turning around, this is more Cassiopeia because you can see Andromeda, and you can see the light of M33. So really, I could have titled this both the Cygnus and the Cassiopeia regions. Milky Way shooting, again, it isn't just shooting the core and then go home inside because it's cold. Shoot at some of these gems here and these other parts of the Milky Way that are visible, and you're shooting light that's like 2.4 billion light years away and on a collision course with us, if it doesn't swallow M33 first. And you're basically seeing three galactic arms in one, and then there are other objects here. There are NGC objects here There's a lot that shows up, even though it looks like just a starry nightscape and you've got the Earth. From our vantage point, we're staring off into a deep and vast universe, and we can see a lot more than we think we could. If this is a dark sky, a lot of this is visible naked eye. So I never stop shooting, no matter how many planes or actual meteors show up to photobomb the shot. With a modified camera for HA, you get this pinkish look, and these nebulous regions show up a little bit more. With when it's fainter, the foreground here. This is a Bortle 4 zone that I like to go to. It's the beach area called Lake Hudson State Park. It's a small dark sky park that's about 30 minutes from your area, David, in Ohio, the Ohio border. So it's most of the good visibility, the darker skies are northern Michigan and northern Wisconsin. But there are some darker skies that are south, and you can at least get an idea of what the night sky really looks like when you go out to these areas. And I think this is the final image that I wanted to show. This is an attempt to pull out the Cygnus region, because here it is setting. Here's Satyr, here's Deneb, here are the other two stars of Cygnus. Of course, there's many stars in the constellation.
That's beautiful.
With about a 45-second exposure tracking, I was able to pull this out. There's ground fog in the distance. And this is one of my favorite farms to shoot, because you've got this enigmatic tree here that
it's very
you
peaceful.
can see that it's very peaceful. Now I've tried, let's see if I can find the image that I shot here prior, before coming back, because I like to take a lot of images and then I plan on coming back and saying, okay, I tried it once, I'm going to try it again, and I'll see if I can find it. If not, it's okay. This doesn't help as much, but come in during day, I shoot this. This is what the tree looks like more up close. And this is what happens when you take your scene and you come back and it transforms completely. Somewhere here, I have another night scene with the tree, but barely any stars visible.
Adrian,
And
there's a question in chat from
Yes.
Tarek watching from the UAE. He wants to know if you can recommend which wide angle lens he should use to go super wide to get those Milky Way images with a small sensor like an APS-C.
An APS-C camera.
Yeah.
Yeah, I would recommend starting around a 17 millimeter wide angle lens that basically it's effectively 24 millimeters. This is shot at around 35. It's actually 37, this particular shot, and that's how big the Milky Way looks. At 14 millimeters with a full frame sensor, this is how much real estate you get. This is back down to the Orion region.
Oh yeah.
Let's zoom in to, with a 14 millimeter lens, you will take a shot that looks kind of like this.
Yeah, that's cool.
With an APS-C sensor. So definitely 14, even 10 millimeter, in order to do a one shot wide angle shot. Otherwise, what you can do is a panorama, and I am going to see if I pulled one off here. I know I had a couple of panoramas that I did. Okay, this was actually shot with an APS-C camera, and this was an 18 millimeter kit lens. So effectively 24, 20, up to 28 millimeters. Effectively, it's an earlier image. I managed to get Earthshine as the moon was setting. And this is a good start for wide angle. Now, if you're wanting to go super wide, do a panorama if you can, take multiple images and then stitch them together. Lightroom CC will actually do it, or Lightroom Classic, as well as Photoshop. In fact, we saw Gary Palmer last week show how he stitches his sun photos together to create beautiful panoramas of the sun. This is made of 2 wide angle shots. The aurora at the winter solstice. I may have a slightly.
There's a lot of color. It's beautiful.
Yeah, there's a lot of color. This one's a little smoother because that's a double cluster right here. And this is the Cassiopeia part of the Milky Way at the time. And you've got a lot of color. There's some purple coming off of here and green. This is actually 2 images stitched together using Lightroom to get kind of that wide. This is wider than a 14 millimeter with a with the full frame. This is 14, and so you see we've got, there's more of this part that shows up. So I definitely recommend all of that to say wide angle lens. 17 millimeter on back. The wider, the better. And the faster the aperture, which we mean lower numbers on the f-stop, f2.8 on down, just helps a lens like that helps bring in all of the starlight. And if you don't have a tracker like I've got, and I've also got an Explorer Scientific mount, if you don't have the tracker, you can still get, with effective 14 millimeters, you can go 20 seconds without tracking and still get a pretty good shot. So that's what I recommend.
Very cool. And Adrian, if people would like to follow you, where should they go?
They should go. I've got an Instagram page, which the handle is simply at ATB Sigma 713. I put that in the chat. We could share it. And then I have both a regular Facebook page. It's just my name, Adrian Bradley, and then Adrian Bradley Photography. And yeah, I will post, especially if I think I've got something that's worth printing, I'll post it up to Adrian Bradley Photography. And let's see what this was. Not all of my shots are great, but they lead up to ultimate shots. So like, here's a different trip. I took this photo and then I show up, same angle, and we get this. So we keep trying. So those are 2 areas. I'll type in a website of galleries. I'm looking to start a Squarespace page because I have sold a few prints and I've had inquiries about them, and I'd like to do a better job of offering prints to those of you that love the photos and wouldn't mind hanging one of these on the wall. This one is actually sold. So I'm typing in a URL with a gallery of some of my older shots. I think this one is on there, Scott. So so that's there. And let's see, if I can pull this off, I will. But if not, just go read Skies Up magazine, and you'll find a special image is on the front of that cover. I've read some of the others, and very informative magazine. Our good friend David is one of the editors. A lot of folks that come on to the Global Star Party have presented. And so it is definitely here's another shot with the Big Dipper in that tree. So I'm going to stop sharing and turn it over because I'm pretty sure I'm past time. But yeah, feel free to check those out. Any prints that you want, I'll work with you. If you would like to have a print or canvas and it will be a fair and a reasonable cost because I use these images more so for outreach than anything, and I'm more than happy to share these images. Thank you, Scott, for the platform to share these images on Global Star Party.
Thank you, Adrian. Thanks
I
for
enjoy
sharing them
doing
with
it.
us. Yeah, and thanks for contributing to Skies Up Magazine. That's awesome. So.
Anytime, Scott.
Awesome. Okay, so up next is young and inspiring astronomer, Conal Richards, who continues to pursue his outreach. A little bit of that is actually here on Global Star Party. He was first introduced to us by Chuck Allen of the Astronomical League, and for good reason, because Conal's talks are inspiring, informative, and really, I would say, honest in the way that he presents what it's like to get started in astronomy, and how that really has affected him, and how it inspires other people around him. So, Conal, thanks for coming on, and you got the stage.
I appreciate it. Thank you very much for the introduction. So as you mentioned, a lot of the work I do is in outreach. And one of the projects I really enjoy kind of working with is looking at targets that are available to small telescopes and binoculars and beginners, because I'm usually thinking back to my first year or two in amateur astronomy. And when I was starting out, I was going through books and magazines. I was trying to learn how things worked and what I could see. So a lot of the targets that I present in my talks are kind of geared towards that and exploring different topics through just a small aperture or binoculars. So, oops, click something. Okay, I'm going to share my screen now. Let me know if you can see this okay.
Yes.
Everyone see my screen? Okay.
Yes.
Excellent
So
background.
tonight, yes, thank you. Of course. Okay, so tonight what I have for you is, well, when I saw the topic for tonight of stellar evolution, and thinking in mind of some of the different targets that I've observed over my time in astronomy and some targets that are easy for beginners, I compiled a small list of some great objects that you can look up with. Most of these you can see in a pair of binoculars and kind of trace the path of stellar evolution for different types of stars. So we're going to start off. I have the time set for December 28th, today's date. And this is around 11 o'clock at night for my location, 40 degrees north roughly. So these are some great targets for northern observers, but there are some wonderful southern counterparts as well. I'm going to start very far north. We're looking at the Pleiades cluster here, the Seven Sisters as they're called. And this cluster, in fact, it always impresses me because of how young it is. It's estimated to be 150 to 300 million years old based on different estimates that I have seen. But in geologic time and astronomical time, that's really not a lot. So if we look at this and think of how far back this goes, around the time these stars started to form, these very young stars, you can even see some of the gas around them in this particular image that Sky Safari uses. There were dinosaurs roaming the earth and all kinds of different creatures that we might not recognize today. So it brings kind of a sense of perspective to a lot of the targets that we look at. The Pleiades, I always think, is really beautiful. It fits nicely into binoculars. And if you can see in the upper right-hand corner of my screen, Sky Safari has this neat feature where it shows you the size of the field you're observing. And this is about 4 by 3 degrees. So if you say a pair of binoculars, a typical pair of binoculars has a field of view of 5 degrees, then this fits quite squarely in there and you can get a great image of the Pleiades. Now, a little farther south, a little bit like the Pleiades, is the Hyades cluster. It's most identifiable by Aldebaran and Taurus here, but interestingly, Aldebaran, this bright orange star here, is not a member of the Hyades cluster. It's kind of superimposed. It's a little bit closer to us than the cluster itself. However, the other stars in this cluster are very bright. They're all 4th, 3rd magnitude, visible in even some light polluted skies for those learning astronomy. So it's quite accessible from a lot of different places. And it also sits quite nicely here on the ecliptic, this yellow line here. So it's easily accessible from both the northern and the southern hemisphere from most latitudes. You can see some wonderful double stars in here, whether they're optical doubles or astronomical doubles, and all kinds of different colors as well. So there's yellow, there's white, there's a little red one in there. It's a really beautiful target to observe if you're in the neighborhood of the Pleiades and you're scanning the winter sky. Now moving out, we're going to stay in Taurus for now. This is more of a telescopic target, but a bright one. It's about 8th magnitude. We have the Crab Nebula here. And if you can see again, I'm looking at about 1 degree here, going up to, top to bottom here. If we're looking at the Crab Nebula, I can zoom in a little bit, but these are all accessible from low powers in a telescope. I found the Crab Nebula looks really stunning if you get some low power eyepieces. And personally, I use a Newtonian reflector, a 6-inch. The Crab Nebula is a really nice target in that it's visible all night from northern latitudes during the winter months. And you can see these kind of sinewy structures in here from this supernova remnant. This star has exploded, and all of its mass, some of which we looked at in the minerals earlier tonight, is spread out in this cloud. And there's these wonderful structures, these veins and these clouds that you can all see in a little telescope. Now I'll pass this over to Orion here. First, we have Betelgeuse up in Orion's right shoulder. If you're looking from the outside in, kind of like some old star atlases, Betelgeuse is very easy to find in almost any sky. It's a very deep orange color, and it's actually a red supergiant. So it's this old star that has gone through much of its life, and it's swelled up quite a bit, and it's giving off all this material. Now, as many of you, I'm sure, remember, back in 2019, Betelgeuse started to dim quite a bit. Its current magnitude is about 0.5, and that's been what it's looked like for most of its lifetime, but it does dim quite a bit. And during that period in 2019, astronomers weren't really sure what was happening. And the answer turned out to be that it threw off this huge mass of material as the star was evolving and dying and slowly moving towards the end of its life. So if we're considering stellar evolution here, we have stars that are just beginning their lives in the Orion Nebula below, and then stars that are ending their lives, such as Betelgeuse up here in Orion. Now, like I mentioned, I'll trace this down to the Orion Nebula here. This is a beautiful target for beginners and advanced astronomers alike. I always find myself returning to it. It looks wonderful in binoculars. It looks great in a wide field telescope at low power. You see M43 here and M42. They're kind of two parts of the nebula. And then inside Orion, if you get some high power in a telescope, about 200 times magnification, you can see the trapezium in here, which is this little cluster of 4 stars forming at the heart of the Orion Nebula. Now, what we're looking at here is what's commonly referred to as a stellar nursery. You have all this gas, all these building blocks of life and planets and stars coming together and forming these stars. So it's quite an interesting place to look for amateur and professional astronomers, all kinds of mysteries to be solved and processes to be happening in there that teach us about stellar evolution, especially the birth of stars. If I can zoom out here, one of the last targets we have here in the winter part of the sky would be Sirius. Of course, it's the brightest star in our sky, very defined as its whitish blue color. And I found that when it's at low horizons, you can even see it twinkling quite a bit if the atmosphere is turbulent. But it's undeniable what this star is. It's a white dwarf, and it's really beautiful to look at. Now, some astronomers have even seen Sirius B. If I can really zoom in here, it's a small companion, very hard to see in a telescope. But you see it has a little companion here. It is, in fact, a double star. But the main component that we are seeing just with the naked eye is very, very bright, and it's this white dwarf star. So what that means is that it's a very dense star. It's also towards the end of its life like Betelgeuse, but it's actually shrunken, and you have this very dense material inside. And moving over, one last target in the winter skies around this time of year is M46. It's a beautiful open cluster in the Messier catalog. And you can see in this image here, there's all kinds of white and red stars, different colors, different stages of evolution and different types. But really interesting about this cluster is a visual and photographic feature, is this planetary nebula inside. Now, when I was looking at this, the planetary nebula was quite bright. You could even see the central star there. And it's this nice round shell, really defined in the telescope. Oxygen-3 filters bring it out really well for those who have those. It really pops the nebula out, and you can study the structure a little bit more when you're taking your notes. But the reason I bring this up, even though the nebula is not part of this cluster, it's superimposed, kind of like Aldebaran on the Hyades, is that you can see different parts of stellar evolution at the same time in the same field of view. So planetary nebulae are how the lower mass stars die. You have a star swell up slightly, then shrink, but also blow out all of this dust and debris and cosmic material that's wrapped up inside the star's outer shell. In fact, our sun will do the same thing. So there's this massive sun, massive shell expanding outward that's been forced by this star's stellar wind. And that's all superimposed on top of this beautiful open cluster. So the open cluster alone is a great target in binoculars, but if you have a telescope, I highly suggest checking out that planetary nebula. Now, to wrap up my talk, I'm going to push us a little bit forward. I'm going to bring us into, this should be June here. So this is June, again, around 11 o'clock. We're going to look at a couple of summer targets now. I have just a couple of these. Most notable, of course, in the summer skies is the Great Hercules cluster. You can see once again, I'm in 1.2 by 1.7 degrees. So this is a very wide field, but the Hercules cluster always seems to grab headlines and titles in astronomy books. It's really a beautiful cluster and quite large, and there's all kinds of features that can be observed with different levels of equipment. Very easy to see in binoculars if you look between these two 6th and 7th magnitude stars, but then it has this really rich core and this outer shell that's expanding out. It's a very large cluster, and for those with larger instruments, I've heard there's even a propeller kind of asterism inside formed by clumps of darker dust and gaps in the stars. So that's really beautiful to see if you have the equipment for that. Now nearby, we have M92, which often gets overlooked, I think, because of nearby M13. It's a little bit of a smaller and a dimmer cluster, but in my opinion, it's very beautiful to look at. A lot of the stars in this cluster have a yellower tint. They're more along the main sequence of what we call a Hertzsprung-Russell diagram. So you have types of stars going along their evolutionary paths. Some are outliers, but these are pretty typical of what the universe has to offer. And they have a very distinct progression from younger stars forming in a protostellar cloud to the planetary nebula we looked at earlier. So you'll find a lot of these stars in a cluster like M92, and then also some aging giant stars like red supergiants and blue supergiants as well. And some final targets in the summer sky would be the Ring Nebula and the Dumbbell Nebula, also known as M57 and M27. I'll start with the Ring Nebula. This was the first planetary I observed in my telescope. And I even found in a 6-inch instrument, you could see a little bit of bluish green color in the outer edge. And I'm still not certain if that's exactly what I saw, but it really does tempt the eye with things you want to see. It looks like a little smoke ring. If you're centering your telescope, your finder scope, in this part of Lyra, you can zoom in, and at about 150 times magnification, you're in at about 25 arc minutes across with this field I'm looking at here. And you see this really beautiful structure. And in larger Dobsonians and larger telescopes, you can even see this central star on the inside. And again, that's how a lot of the low mass stars die. Now, looking at a planetary from a different perspective, the Ring Nebulae, we're looking straight down into the core outside of the stellar wind, so it's much easier to see. But here we're kind of looking at the edge in the Dumbbell Nebula. This one is much larger and very easily visible in binoculars. I've had a lot of fun with this during the summer and viewing from campsites and dark sky places. It's a really beautiful nebula. And it almost looks like an apple core. Some also say it looks like a dumbbell, of course. But you see this really distinct shell with these outer edges, and then this kind of cloud in between. And then once again, there we have our central star pushing all of this gas out. So if we zoom out here, we have some wonderful targets in the summer. And if I go over, kind of looking through the Earth, we have some great targets to view in the winter as well. So I really hope those new to astronomy and those interested in stellar evolution are able to get out and see those. Those are some really beautiful targets in my opinion, and I've had a lot of fun with them. So thank you very much.
Thank you very much. It's great to have you on again, Conal. I feel like I've been to an amazing planetarium program, so it's great.
Hey, Conal, can I interject something quickly, Scott?
Sure.
Please go ahead.
That's great. And I really enjoyed that. And your enthusiasm and your knowledge is extremely impressive. There's a strange thing about the Pleiades. For many decades, it was believed that the reflection nebulosity, the dust, was associated with the formation of the stars. As you said, they're young stars for an open cluster, about 100 million years old or so. But the motions of the dust and the stars are very disparate. So there are some recent papers that demonstrate that the cluster is simply moving by chance through that dust. They're astrophysically unassociated, which is interesting.
That's really fascinating. Thank you
Yeah.
for sharing that.
So
Yeah.
and that's just just last some few years, a sort of an
That's-
oddball fact about the Pleiades.
That's a gem to keep and put in the pocket, because anytime we describe the Pleiades, right, these are young hot stars, they're giving off gas and dust, and that's what we're imaging. And you're telling us it's not the case. So
And of course, it was a totally logical assumption. For a century, everyone thought that this is obviously the leftover dust from the formation of the stars, but it turns out not to be so. So the universe can throw a curveball at us.
Oh, and that's
Well,
the
like
good
the-
thing. Yeah, good thing about science is the continued. You learn things as you go, and you pass these along. So it was known as dust, but then last few years, someone took a closer look. Oh no, it probably isn't dust at all. And or it is dust, but it's not
dust.
directly
It's a dust
from.
cloud, but it's simply moving through that dust in its
Yeah.
motion through the galaxy. Yeah.
So it's not directly from those stars,
Right.
even though they're so. And a quick question, are there other examples of those bright, hot young stars that are producing the gases and the dusts that we see? And I guess M42 comes to mind.
Yeah. Now, obviously, almost all emission nebulae, have a lot of formative gas and dust still involved with very young stars. And, those early Hubbell images of protostars in the Orion Nebula, proplyds and so on, those are
Yeah.
literally, stars that are proto-solar systems that are just forming. But there are quite a number of reflection nebulae on the sky with dust that is believed to be associated with the formation of those young stars. Yes. So this is an oddball sort of, exception. And it's one of the most well-known open clusters in the sky too. So it's kind of weird.
Yeah.
Those
No,
chance
very
encounters.
interesting.
Those chance encounters are really fascinating because I mentioned with some of the objects in my talk, we have that one open cluster M46, I think it was, with the Planetary Nebula right in front of it.
Yep.
And you also have Aldebaran and the Hyades. It looks logical to say, well, there's a star and it's a part of that cluster, but our perspective is just, lining these up by chance. So it's really beautiful to see visually, but there's so much more to be seen with the astrophysics, which is wonderful.
And of course, there's so many optical double stars. There's so many stars in the sky. There's zillions of examples of optical double stars that are at different distances, that are not binary stars gravitationally associated, all over the sky, that are just chance alignments, that appear to be double stars. Lots of those. Yep.
I think Albireo is one of those. Is that correct?
Yeah.
A famous example.
Yeah.
We at Michigan call it the maize and blue star. I had to throw that in. That was one of the first things when I the first astronomy club, the Lowbrows. It's one of the stars we would always look at in the summer, high in the sky, and the astronomers would proudly brag, "This is the maize and blue star." And since I graduated from Michigan, I simply assumed that, and I take that on now. So, but that's another. I think I assumed that was a double star with them orbiting, and apparently they are not. So, I'm learning a lot of things here on a Global Star Party tonight, so I'm very grateful.
That's a good one too. I mean, it's hard to get a star pair of stars with more beautiful color than Albireo presents. That's a beautiful star field.
I think there's a triplet in Cassiopeia that can give it a run, but I forget the
Iota Cancri as well.
name.
Yeah, Iota Cancri. Yeah.
But I know there are a few of them, but I'd have to go back to Sky Safari and start looking for them. So that that's always a go-to, even when it's cloudy and we have to show them something. We point it right at Albireo.
Yeah.
And we try to remember the name Albireo because it can be a hard one for me to remember. But and people go ooh and ah.
Oh, yeah. Oh, it always impresses people. If we run out of other things, Scott, we can do a whole night of double stars someday.
Okay, we will. We will. But before we do that, I have to get to our new guest, Cheyenne Smith. Cheyenne is doing some important outreach work in Tulsa, Oklahoma, which is really close to us. You know, I was so excited to find her and to learn about some of the things that she does. She's relatively new to, the community of educational outreach and astronomy. She's been doing it for just a few years, but she's already a NASA Solar System Ambassador and is involved with organizations or, at least one organization that is dedicated to educational outreach and astronomy. I'm going to let her talk about it and introduce herself a little bit more. We did have some conversation earlier today as we were practicing on Zoom, but I'm going to turn this over to you, Cheyenne. How do you feel about your first Global Star Party?
Oh, I love it. I love it so far. I've really been enjoying the night. Thank you, Scott, for having me.
That's great. That's great. So as we're still kind of new to each other, I'm going to let you talk about yourself a little bit and some of your experience and getting involved with Science Heads, which is a program that you're involved with. But I know you're also involved with artists, the artist scene in Tulsa, and that you have taken on some ambitious projects to do educational outreach in astronomy. So I'll turn it over to you.
Yes. So I started out talking a bit about myself. So I'm sure, like some of us, I was always fascinated by the stars and galaxies, and wanted to know about the universe and our place in it since I was a kid. I was obsessed with crop circles and UFO abductions, but that thankfully turned into something more or evolved into something more sophisticated, which is astrobiology. So that's something that I'm interested in and am like looking to pursue. I recently was in a graduate program for studying archaeoastronomy, but now I'm looking to pursue a degree in planetary sciences in pursuit of astrobiology. So like Scott
Good luck
said,
with that.
Huh?
Good luck with that.
Oh, thank you.
I'm rooting for you. Yep.
Thank you so much. But as Scott said, I'm also a solar system ambassador. I've been one for almost 3 years now. I'm also the chapter coordinator for Science Heads here in Tulsa, which is a nonprofit headquartered in California. So in both volunteer positions, I aim to make STEAM activities more visible and accessible to marginalized communities locally. To do this, I've conducted star parties, both in person and virtually, and have spoken to panels and been involved in other science communication opportunities to talk about my love for astronomy and the search for life throughout the universe. And the STEAM part comes through my arts worker position here in Tulsa. So I work full-time for the Tulsa Artist Fellowship, which is a residency. We currently have like 45 artists. It's an artist residency. We provide them like, a housing stipend and a studio and all this other stuff. Well, we subsidize their studios and their living here in Tulsa, in Tulsa's arts district. So
That's great.
Yeah,
a lot of poor artists, as there always has been, but
yeah. There's so many. They're wonderful artists. I highly recommend you all going to our page and checking them out. They're pretty great. So just a little plug there. But so to further my efforts, as mentioned previously, I started a project to build a mobile observatory to be featured in all neighborhoods locally. This idea kind of stemmed from me wanting an at-home observatory for the longest. Then that evolved into wanting me to build an astronomical experience here in Tulsa to make these kinds of places like observatories easier to get to. So I started doing some research and actually found a couple of other organizations who have built like these mobile science centers, but was really intrigued by the design Science Heads had engineered. And so I ended up reaching out to them to start a chapter here in Tulsa, since our visions were like very much aligned. So to give you more of a visual, I have a video and a couple of slides I can show you.
By the way, you got some very cool glasses on.
Thank you. These are my prescriptions too. I'm actually blind, y'all.
Kind of open clusters, you know, so,
Yeah.
right?
Yes. I love them. I say Elton John has nothing on, you know.
Yes.
He's right here.
Well, if the style points contest, you've won hands down.
Oh, thank you.
We give you get the trophy.
Thank you so much. Can y'all see my screen okay?
Yes, we can
Your
now.
screen.
There's
Yeah.
Okay.
Can you bring that up full screen, or is that?
Is that there? Okay, is it there?
yes, it takes it a little bit, but it gets there. So we can see it full screen now.
There we go.
Okay, great. Oh, please.
I always knew I wanted to be a scientist and an astronomer. I didn't see anybody that looked like me doing it. I really want to be able to inspire young minority communities through my passion for astronomy. My name is Cheyenne Smith, and I'm a builder from Tulsa, Oklahoma. A lot of people don't realize that they have this passion for space until they see that dark sky with all those celestial objects and they see the Milky Way. They don't know that they have this passion until they're introduced to it. I started doing star parties around Tulsa. Everybody brings their telescopes, their binoculars, and they go out and we just stargaze, and people loved it. That's why I started this project to build a mobile observatory. The mobile observatory, it's a trailer, it's nothing fancy right now, but what I'm hoping for is to have a whole astronomical experience inside and on the outside. I'm bringing science to you, literally. I was really excited when I got the Builders and Backers grant because it was reassuring that this is something that is needed in Tulsa. I want it to be right in your face, that this is here, this is your resource, I can be your resource. Let's get to the stars.
So here
Right. I'm going to put in a link to the GoFundMe page
Oh, thank you so much.
about this.
So a couple of other visuals. I think I always have trouble with Zoom. I always knew
Okay, we've all been through this.
There we go. There we go. Okay, so this is the mobile observatory that's located in Science Heads in Orange County, California. As mentioned briefly before, the observatory is designed to, the one that I'm building as well, is designed to be a primary outreach tool for educating children and adults about astronomy related topics. Each outreach will be designed with a specific objective and audience in mind. As such, the topics covered will vary from outreach to outreach. The mobile observatory is designed to allow for maximum amount of flexibility. Topics covered include, but are not limited to, solar system objects, the Milky Way objects, solar dynamics, astronomical events, and so forth. And these are just a couple of, here we go again. Hold on, sorry y'all. There we go. These are very old renderings of what can be expected on the inside. So you have two monitors here that would be used for, like, cloudy days. I can, upload some simulation software onto the monitors and still do some programming. And also that's where artists can come into play too when we, co-partner and do some programming planning together. And then the telescope, and then you have the pier here that the telescope would be mounted on. And then of course a little desk and, a chair and maybe some other things. But this is just a really rough draft of an early rendering of what that can be expected on the inside. And then This is just a very rough draft of the pier that's to be built.
Oh, so does the pier go through the floor and hit the ground, or how does
Yeah.
it work?
Yes, it's mounted to the ground.
Okay.
Yeah. Yeah.
So many questions. I'll go with the questions I had before. I was going to ask another question about the pier if it comes up, because you're saying it's mobile, so it obviously can't stay on the ground, but it goes through the floor to the ground to steady itself when you park the mobile observatory.
No, this thing is it's mounted to the actual floor of the trailer. Really.
I see.
Okay.
Mhm.
So yeah. And the other question was the telescope intended to be a visual thing, or were you going to consider astro like live, or what they call EAA, which is like live view astronomy using it?
You mean like, do I plan on doing virtual astronomy with it,
or just basically it's live astrophotography where you have a camera on the telescope and your two screens then show the image of what your telescope's looking at? Or were you going to have it be visual where you have an eyepiece and you let people see these things?
It's going to be very visual. I haven't gotten to astrophotography yet.
Well, you've got plenty of resources that could help you turn that into, but first things first, of course. And of course, I was thinking, I shamelessly think about your outreach and how it might reach the hood areas. And I've shown people or pointed at folks, and the love of starlight from hood to all walks of life will look up and you point at something and they'll stop. Doesn't matter what street, what side of the city they're from. Is that one of your goals, to set up an outpost and let folks come in and see something that they may, with all the street lights, haven't had a chance to look at? Because everyday life, there may be some other things going on. Is that kind of a target for you out there in Tulsa?
Yeah, no, that's my main target my main target audience is underrepresented communities. So I plan on going, like, thankfully in Oklahoma, we have really dark parks that I have already been in correspondence with and having this thing like there on a monthly basis. And so we have north, south, east, west Tulsa. My primarily target is North Tulsa because that is primarily the
hood. We're just gonna say it. Global Star Party hood. That's where folks are. Life can be a little rough in underrepresented urban community, aka the hood. We want to spread astronomy to our folks out there. Like I said, it's
out there. You have great schools out there. You have McLean High School, you have Booker T High School, and there's a park, O'Brien Park, that's really dark at night, and I know there will be I've already gotten a lot of interest in people wanting to get
that's wonderful. Keeping in mind, of course, this idea you have is a very global idea, so I don't see it limited to the hood. I think you're going to be going to a lot of different neighborhoods, different groups, just people in general love the stars. And I think that this has even far more potential than just, the main goal. Of course, we got to do it one step at a time. Scott, you said you're going to share the GoFundMe page, and
I did.
Yep. And I have a lot of interest in where this goes. Outreach on one hand, when I share pictures, for instance, and I share them with, the friends and family from Detroit, and no one has looked at them and said, I don't have time to see this. They're all looking at it. That's really good. I get the same answer no matter what the backgrounds are. It's truly space is truly a global human thing to, want to enjoy the stars, and regardless of where you're from. So, I really am excited to see how well, how your outreach efforts go.
Thank you.
And
So
hopefully
much.
I hope they, not just to the hood, but reach everybody. I mean, this platform is a great platform. It's a global thing. You're reaching folks in different countries with this idea. So, you never know what this could spark, and hopefully it does really good. And looking forward to seeing how it grows.
Thank you so much. Yeah, that really means a lot to me. I've so far I've raised about $15,000 for this project. Of course, I need more funds for this. It's kind of ambitious, but thank you, Scott, for posting the GoFundMe.
Sure.
Yes. So so yeah, I have so many ideas for this project, and it just gives me goosebumps every time I get to talk about it. So I'm just so thankful to be here tonight. And thank you so much for your responses. That was all that I have for my slides. But before I close out, Scott earlier had asked me to explain a bit of why I do what I do. And kind of how what Adrian was talking about, it's all due to this cosmic perspective. As you all know, in astronomy, you all often hear astronomers speak about the concept of having a cosmic perspective. And I think, Dr. Tyson said it best when he said something along the lines of like, when you start to study more and learn more about our cosmic address, and you start to realize how more alike we are than we are different. And that's exactly why I do what I do. And this kind of perspective is something that drives my work and my passion. And I want to try and embed that in others that I come up in contact with, especially with this project. So thank you so much for having me. And I can't wait to see more of the night. And if you want to reach out to me, I can put my information in the chat box and go to Facebook and do that as well.
Sure.
Please
If you
do.
want to just put links up, I'll share them with the simulcast chat. If you
Perfect.
like.
Thank you.
Okay, so we are going to take a little bit of a break, and this will be time for you to get a sandwich or a coffee or stretch your legs a little bit, and we'll be back in about 10 minutes. You're watching the 78th Global Star Party, The Amazing Life of Stars.
¿Qué onda, Adrián?
Maxi.
¿Qué onda? It's like more, what's up?
Yeah, I plan on getting my Spanish. I wanted to say "Cómo estás" just by
we say here,
that.
¿Cómo andas?
¿Cómo estás?
¿Cómo andas? How are you going?
Okay, ¿cómo andas?
Andas.
So it's a little.
We put the accent at the end.
At the end, andas.
Andas. Exact.
Okay, so it's there's definitely the dialect that I have to learn.
Yeah, it's not the same here. For example, in Mexico or maybe Colombia or Central America, it's a different kind of tone that we have. Of course, here in Argentina, we have from where I'm from, we have this accent like porteño or de Buenos Aires. But if you go to Córdoba, they has more funny accents, because, for example, ¿Cómo andás? It's more large. No, it's very cool, and
Yeah.
obviously it gets stuck with you when you're living there, it's impossible to not talk like them. Hey, Beatrice, how are you? Here's
Yeah, Beatrice. Hello. Norm is saying, yeah, get your name on the big screen, type away. And of course, no one's doing it. They're all they're all going to get something to drink.
I don't know if you hear some kind of noise or you hear me good, because I'm using a wine blow here. It's really hot this summer. Today we had 41.
Yeah, that's right. It's summer now.
Yeah,
I gotta time it so that I visit you now when it's cold up north. But carry on. Yeah, it's.
I invite you
make my
for
plans.
the cold weather. You know, it's
Yeah.
really suffocating.
Right, except it's the cold weather when the Milky Way goes directly overhead for you, though, right?
Yeah, exactly. Yes.
Yeah, so it's like there's giveth and taketh away. What part of the Milky Way do you see during your summer month?
Practically we see almost the southern, because
So, a lot.
Yeah, from the Southern Cross, well, the Saco de Carbón, and for what is Omega Centauri, some kind of that place, and also we see the Orion arm, of course, the Orion constellation, Tauro. The oldest zodiacal constellations we can see it from here, but we must see that part in the south, like you see, for example, the North California Nebula, I think it's called, or not North American Nebula, for example.
Yeah,
we can't see it from here.
Yeah, that's yeah, all the images I was sharing were mostly Cygnus region, North American Nebula showed up in a lot of them.
I don't know if I have some picture. Now let me find it to put in my background. Well, here's the Leonard comet that
I should change my background, although I like the I like the nebulosity of this one, but
it was in this time of the year.
So Viramus Corkil raining here this week. It's sunny somewhere. It is always sunny somewhere. Those of you that are dealing with clouds, snow, and rain like I am.
This is the part that we see.
Oh, look at that. Yeah. Coalsack Nebula, I think.
Coalsack, exactly.
I'm
it's
seeing
really,
the Coalsack.
Really
yep.
Let me.
And then the crux is near there.
Here's Hadar, Alpha Centauri, or Rigid Centaurus. And when you continue, well, you can point from there, and in this place is Omega Centauri.
Centauri, okay.
Yeah, and in this place, in the center is, I think, the Southern Cross, and here up is the Carina Nebula. This is an amazing place
there it
to
is,
watch
yeah.
it. Yeah, it's really enjoyable watching that place. And of course, there's a lot of dark nebulosity, and this is the most part that we see, and then we continue to the core of the Milky Way.
So yeah, it's a complete opposite of what we normally see. Right now, we're seeing the Cygnus region set to the west, which is a beautiful sight. I forgot to share that in my presentation, how beautiful the Cygnus region looks at a dark site. When it sets to the west, it's this bright, beautiful area. But then I did share what the Orion region can look like. It's an often unheralded area, but more Milky Way shooters are beginning to get their modified cameras out, and they're beginning to shoot those areas because they're seeing some postings, and they're starting to realize that area, if you process it right, can look a lot. There's a lot more there than you may think. So there's a lot of processing and a lot of nightscape shooters are trying to shoot it.
A lot of time.
A lot of time, but it is cold. When it's cold, sometimes it's frigid, and you got to be ready. This is a new Christmas gift for me. Is this camouflage
nice
hoodie?
Nice sweater.
Yeah, and so I wear it. If it's cold, I wear it under the coat, and I go out there and I work.
You have to
it.
be prepared.
Yep.
To get
definitely.
Outside. Yeah. No, here I'm only a t-shirt, and it's
t-shirt and barbecues outdoors.
I did a barbecue with my father. Also, Merry Christmas for everyone.
And Feliz Navidad.
Yeah, exactly. And I did a barbecue with my father last Friday, and it was kind of enjoyable, but it was a really hot night here. Well, people from here, when we see Santa Claus and we see the snowing season, and when I was a child and saw cartoons where the Christmas is with snow and cold. Here it doesn't.
Yeah, here it's beautiful. I'm gonna make a point to the chat. I just realized the James Webb Space Telescope did launch. I think that counts as a new telescope, so that means the whole world's gonna be cloudy because we all got a brand new telescope.
Yeah.
So if it's, for those of you in the chat, if it's cloudy, it's because the James Webb Telescope launched and is continuing to successfully unfold all of its science instruments as it gets closer and closer to its final spot, Lagrange point, the L2 point that it's going to orbit. It's going to orbit from. So that explains everything. Because we got snow again over in Michigan, and it was just 50 degrees on Christmas Day. Suddenly it's snowing in 34. So thank the James Webb. And Veramus, the formula is any new telescope, the bigger the telescope, the more you affect your region. With James Webb being as big it is, it will be cloudy on the moon. Yeah, that's liable to happen. But it will, the sun will shine again once it gets to the Lagrange point. So it won't be cloudy forever. Some of you are lucky enough to be where it's not cloudy at all. So you're defying the telescope thing. But we're all glad that it launched. I think we all we're all happy for that. So maybe.
Okay, we're back. We're having a little change in our schedule tonight, but I wanted to bring on Dr. Marcelo Souza. Marcelo is the editor and coordinator for Skies Up magazine, along with David Levy. But Marcelo has been the force of coordinating this and reviving the magazine, so we're really happy about that. He is also a professor of astronomy, and he is a cosmologist down in Brazil. And he has led many amazing programs about astronomy and astronautics, and has had such speakers as Dr. Buzz Aldrin and many other famous astronomers and astronauts at his gatherings. He also had a long-running television show devoted to space science and astronomy. And he is right now leading a group of young people to explore the universe in a special program that he will be talking about. But it always amazes me how many things that Marcelo Souza has been involved with, and he's a fountain of inspiration and energy. So thank you for coming on, Marcelo.
Thank you, Scott. It's a great pleasure to be here, and thank you for your kind words.
Yeah, we have been highlighting some of the articles in Skies Up in some of our other programs. So it's been really amazing, and thank you for getting these people to submit articles.
Well, thank you, and thank you. I would like to thank everybody that sent the articles and send contributions to the magazine.
Including the cover page. Yay. Okay, sorry, I had to.
It's a fantastic astrophotography that is in the cover of the magazine.
Congratulations,
thank you,
Adrian, for that.
Thank you, Adrian. I will show now here today. I will share my screen. I have a fantastic news about here, what's happening here in Brazil now. Here. I think that now you can see the screen.
Yes,
I forgot to say when Scott said that we had invited and received many people associated with astronomy in your country. One of the person that participate here was Scott Roberts that visited us. It's a great honor to have your participation here.
Thank you.
And before I talk about the news that I have, something that is important because many people don't know about the seasons here in our country, Brazil. You have the solstice, is the summer solstice for us here. It is very hot here now, today here in my seat.
Yeah.
But few people know that Brazil, as it is a big country, the equator line here cross near here in the northern region of Brazil, and part of Brazil is a small part of Brazil is in the north region, in northern hemisphere. Most of Brazil is in the southern hemisphere, but a small part of Brazil is in the northern hemisphere. And in this region, that is the Amazon, we can't talk about seasons as we know, as you have in United States or in Europe, because here it is hot during all the year. What is different is because you have a part of the year that you have a lot of rains, and part of the year that you don't have so many rains. Then they call these two different moments winter and summer, but it is hot every time. You have a part of the year with rains, a lot of rains, a part of rains with not so many rains. And then when we talk about seasons, like United States, you have United States and Europe, for the people that live in the north region of Brazil, it is difficult to understand because they don't have winter there. The winter for them, as I said, is a region, is a moment, the summer winter for them, they use these words only to say that during one moment you don't have so many rains, in other periods you have a lot of rains, only this. But it is hot during all the year for the people that lives, that lives near the equator here. I live here near the Tropic of Capricorn, that cross, it's a part of Tropic of Capricorn in Brazil. We can locate it here, is a state near us, that is São Paulo. Our latitude here is 21 and a half here in Rio de Janeiro, until the capital of Rio de Janeiro. Then for us here, it is hot, it's our summer. But you have part of the south region of Brazil that is below the Tropic of Capricorn also. Then you have different seasons here. And the winter in this region here, in the south region, it is not like in United States and Europe, but it is cold. for us here, when we have the winter in the middle of the year, we have 20 degrees. Nobody wants to walk in the streets because it's very cold for us.
Oh,
20 degrees, 16 degrees. It is very difficult to have this temperature here, but when we reach this, nobody wants to walk in the streets. It is very cold for us. I know that
Right.
for you is almost the summer in some place, 20 degrees, but here for us it's very cold. No, this is only to show that as is a big country, we have different seasons here. And in the northern region, you don't have, you can't talk in seasons like you talk in United States, in Europe. Here for us is different. I live here in Rio de Janeiro state, and I will talk now about what happened here in our state. It is very hot now. Here is the image of the Copacabana beach that is very famous in Rio de Janeiro. Now is the time to go to the beach here, when the people that live is near the coast. But here, I live here, almost here in this place, that's campus. Here you can see a dark green region here, that you have a forest here. That's a protected forest in this place. It's a state park that protects the forest. And now here, you can see now, this region here. Here's campus, here is this region here, near us. The headquarters of this park is located almost 100 kilometers from us here. This is the state park of Desengano. You have this kind of monkey, they protect them with another animals. And now we had the announcement for the International Dark Sky Association that this park now is the first dark sky park of Latin America and Brazil. The first one in Latin America and Brazil. They
excellent for that.
They chose to protect the dark skies. And I showed some images of the park in other programs. Here in the Global Star Park. Here is the park. The total area of the park is 224 square kilometers. But if you include the region around the park, it's more than 1,400 square kilometers in area. And it is part of the parks. We have 3 cities here that the park is inside 3 different cities. And what is important here is that in all this region of the park, they don't have artificial lights inside.
No lights.
No lights. They don't have electricity inside the park. And they sign a commitment to be considered as international dark sky park, that they will continue with this. In the next years, they will not allow any kind of artificial lights inside the park, and you will not find any kind of power, electricity power inside the park.
No power.
No power.
So if you're going to bring a telescope that has power, you need to bring batteries, I think.
Yes, yes, you need to bring batteries because you don't have power inside the park, and you continue like this. You can see here. This is the dark part here. Here is campus, our city. That is the biggest city of the region. You can see here the lights in our city. And here is the park. Inside this red circle here. You see that you can't see any kind of lights here inside the park.
Nice.
The headquarters of the park is located far from the park, is here. In this dark arrow here. Here's the red part of the park that is located 20 kilometers far from the entrance of the park. And here is near the nearest city. That is a small city with 10,000 people that live there. That the name of the city is Santa Maria Madalena. they are celebrating these moments in this city because it is very important for them to receive this recognition, international recognition. And the city now is changing the lights to be according to the suggestions made by the International Dark Sky Association. They're changing all the urban lights of the city.
That's really good because I think you'll have that light dome to the west, but all of your eastern, northern, and southern, you'll have a bit of a light dome to the south too. But yeah, especially in the center of that area, if everyone does change their lights in the surrounding towns, you look like you might be able to be on the borderline of achieving a Portal 2 zone right in the center there. That would be that, yeah, the sky really pop out. So that's really good.
And also, Adrian, what you have here is that you have mountains here around the park.
Oh, right. Yeah.
You
Right,
have
so even
mountains
better.
here.
So it'll block the light
Yes.
with the mountains,
Yes,
making
you
the
have a
view.
lot of mountains here.
And
The park is near 800 meters from more than 1,000 meters.
Oh, wow.
Okay.
High.
Yeah, so it's up there. Do you have, what Bortle rating do you have in this area?
Sorry?
What Bortle rating, as in darkness rating? I know you got the designation, so I'm thinking those come with at least like a Bortle 4, which, you know, you still have some light domes, but it's dark enough to,
Yes,
you know,
it's dark
see
enough.
some.
Yes, it's dark because they measure inside the park in many places inside the park. The lighting that they have, and you have parts of the park that is absolutely dark. You don't have any kind of lights. You can't see lights. You can't see the cities around.
Okay. Yeah, I
From some
imagine.
here is the region. You see this red arrow here.
Oh yeah, you know what? I
This
see
is
that little spot. That's
yes.
your
This is
darkest of the dark.
Yes, this is a part of the park that they chose to allow people to put telescopes in this region.
Yeah.
This is
And
a
I
special
see.
part of the park that people visit. They can use in many places here, but it is a big forest. I don't know how to say in English, but you have
Nope, that is a big
trees,
forest.
and it is different. It's different from the forest you have in United States and other places, because the
Yeah.
forest is closed. It's closed
Yep.
because the top of the trees,
the canopy, the tree
you
canopy.
can't see the skies inside the forest.
That makes sense.
And then
Yeah.
you need to find places in this region to allow you to see. And most of them are near the border of the mountains.
Mm-hmm. No, that makes sense.
I'll show here. This is one of the picture. From the red, here is not inside the park. This image was taken 20 kilometers far from the entrance of the park. And here you see he puts a artificial light here, a flash, and here you can see the sky in this part that is not inside the park.
That's not even inside the park. Wow.
It's not inside the park. It's absolutely dark there. I was there.
Yeah, it's still.
So
yeah,
I have a question for you, Marcelo. Being that the park now has international dark sky status, how is that affecting the local economy in the area? How are they responding to that?
They are planning now astrotourism activities here. They are planning to receive tourists there.
Yes.
Then they are training the students. They are training the population. They are training the security of the park, and they are planning to organize activities inside the park, events, for astronomy, associated with astronomy, for astronomers, and for the population. Then you imagine in the city that is near where is located the headquarters, they live only 10,000 people in all the city, the city, but near the region, downtown, you have almost 5,000, 6,000 people living there. And they received international recognition now. Then everybody in the city is talking about this. Right? The schools of the city now, they are planning to have classes of astronomy. They are preparing the students and the population to receive the tourists that are planning to visit the park, because it is the first one of Latin America, right? That they have there.
Yeah.
They change everything. They now is changing the lights of all the cities. Right?
Yes.
And then it's something that is amazing that's happening there. Right?
It's you and now your group of young students there, were they involved also in popularizing or supporting the idea of a dark sky there?
Yes, we participated in the group that was responsible for the recognition. All the project was made by the staff of the park, but we participated helping with the astronomy part of the project. Then we were responsible to help and to give support for all the astronomy informations. We help them to measure the lighting inside the park, and we participate in events in the city in the past. Then everything began because in the city, when we organized the first activity inside the park, we met a British guy that he is member of the International Dark Sky Association.
Great.
And he motivated the park to become an International Dark Sky Park.
Oh, that's great.
And they asked our help and support. And we participate since the beginning of the project.
That's wonderful.
And now all the project is available at the homepage of the event. This is the official announcement in International Dark Sky Association homepage. I have here, I will share the page because I will show our astronomy club are there in these announcements. I will show now, I will stop here. This is the group, one of these, Samir, was one of the guys that was responsible for this recognition because he made all the measurements inside the park. Let me show here, I stop here. I'll show the page. I'll share now the home page.
I've got it right now. I have it.
Okay.
I will share it with our audience.
Okay. I think that I have it here, but let me see.
Yes. Yes. I'm sharing the same page.
Here. And here we have Santa Maria Madalena's name is Desengano State Park, administered by the State Environment Institute, achieved an unprecedented title in Latin America, the nomination of the protected area as an International Dark Sky Park designated by the International Dark Sky Association. It is the first one in Brazil and in Latin America. The name of the park is here, Desengano State Park. And here is our group, the Luis Cruz Astronomy Club. We were involved since the beginning of this recognition. This is something fantastic. I have a map here to show how it is important for us here. Here. Here was the locations of the communities and dark sky parks around the world. You have many different kinds of dark sky places. You had a community here in Chile, but it's not a dark sky park, it's a community. And now here is will be in the map the first dark sky park of all Latin America, including Mexico, until Argentina and Chile here in the south region of South America.
Wonderful.
It's the only one that you have in this region.
So we need to make this whole map just solid green, right?
Yeah.
I think that's the goal.
Yeah, after the announcement, I received contacts from other groups in Brazil that want also to be recognized as a dark sky park. I think that soon we will have other parks here in Brazil, and I hope in Latin America.
Yes.
It's something that motivates many people.
There's a lot of work still left to do, to educate people about dark skies. Mike Wiesner, who sometimes is on Global Star Parties, pointed out that if communities just use smart lighting, not no light, but smart lighting, that they could save enough money to apply towards organizations that feed the hungry of the world, just by reducing the way that we use light. The money that we would have spent could feed all the world. And so a lot of times people make arguments about, oh, let's just pick one, like the James Webb Space Telescope cost $10 billion. Okay, that sounds like a lot of money, but we waste that kind of money just by using too much light. So that's if we got our priorities straight and used our resources better, many such things, such as light pollution, curbing light pollution could feed the world. So
here you can see the city here. This is a small city that I said, and here is the park. These mountains that you see here is located in the park. And I'd like to congratulate the staff of the team of the Desengano State Park, because they did a fantastic work, coordinated by the name of the manager is Carlos Dario, and he has the support of two guys, fantastic guys, that is Samir, that is photographer, that they made all the measurements, and the João Rafael, that was responsible to write the project. And it was fantastic. This is something that we are very happy. Is a gift, a Christmas gift for us here in Brazil, because it was announced near Christmas here, celebration of Christmas. Now they have the recognition here. And the other wonderful news near Christmas was the launch of the Skies Up magazine. The new edition is about the light, how to protect us from light pollution. You have 3 articles about this in the magazine, and the cover images from Adrian. Thank you.
Yeah,
Adrian.
there's
it's a nice cover shot there.
Yeah, for those that saw the presentation, that's this part of the Milky Way, Kenton, Oklahoma. There's a little bit of sky glow there. You can really dig in with I think this is just a 30-second tracked exposure, and all of these things, the California Nebula, some of the gases that we learned from David Eicher that the Pleiades are passing through. You can kind of see that here, the Hyades that Conal talked about, Lambda Orionis as a part of Orion, and the Rosette is here. There's other nebulosity that's all around, and the darker the skies, the more you can image, in the night sky. And this is a perfect example of things. I didn't know that this is what this part of the Milky Way looked like. I had tried to image it back in my home state of Michigan. So when this came out, it surprised me. And all of the dust lanes here and everything. And this may have been the first time I saw this part of the Milky Way. So
well, wait till you get
definitely
to
an image
Desengano State Park and do a Milky Way shot. It'll blow your mind.
I have to. I look forward to that.
And then on your way to Argentina. Okay.
Yes,
so
on my way. So many places to go, so much to do. But yes, and in actually reading Skies Up, you know the articles by Marcelo and the rest. It's definitely a wonderful online magazine that I follow.
That's great. That's great. Thank you.
Thank you. Fantastic magic. If you want to visit us, you'll be welcome here. If you want to visit Brazil.
Go ahead, Marta.
Okay, you'll be welcome. I will share here and now the magazine here on a moment. I have here. Can I show you, Scott?
Of course.
Magazine. Quickly
Of
here.
course.
Here is the homepage where you can find all the magazines.
Yes.
You have all the magazines here. Then you only need to come here and click it. All the magazines are free.
Yes.
And here is the last edition. You have articles from Morocco, Romania. I don't know if I said correct in English.
Yes,
because in
Romania.
Portuguese is Romania. His Portuguese is Romania, that they say. Here is an article from Dr. David Levy about the memory. Here is an article, some information about the last. Here is from Morocco, from Hassan, our friends. Here images from astrophotography from Romania. And sorry, from Morocco. Here is from Romania. He's from Canada, Quebec, né? Is a model of a park, Dark Sky Park, the first one. I believe that was the first one in the world. Here is when we finished the magazine, it was recognized this city is a dark sky place in Bisei, in Japan.
In Japan, yeah.
In Japan.
Yeah, look at the difference in
the lights here.
Controlling the lights.
It's a fantastic article. Here you have an article from the outreach, is the Night Sky Network from NASA.
Yes, yes. David Prosper from Night Sky Network. That's right.
Yes, it is a fantastic way to know if how is the sky near you. Using the Orion as a reference for this. Now is an article from Pierre Paquette from Canada about the planetary orbits. He made a long study about this.
Yes.
Here is Pierre. Astropoetry from Romania, from Valentin Grigory and his friend from Romania. And I have a lot wonderful astrophotographies from many fantastic astrophotographers. And the magazine is available for everyone. It's free. It's fantastic.
Yeah.
Thank you for the opportunity.
It's an honor to be, to have an image up with all the beautiful images that are here. Looking at Andrew Fryover's image, he's captured some of the dust lanes that are in Lambda Orionis. and he's got some of the same detail that I had in my shot with his panel mosaic, and it's a beautiful undershot region of the Milky Way that you really can only see, if with your eyes when you're someplace dark. And I've tried to shoot it back in Michigan ever since, and it may not come out quite as well, but it's still a beautiful area of the sky. And that I would hope would be my fate, that seeing that caravan there, or not caravan, but camper, reminds me of all the things that I saw when I was at Okie-Tex. All the campers and RVs and people looking up, and a lot of astrophotography. So there's a lot of red lights around of people just aiming at the stars. And it's a beautiful time, whether you get a good picture or not. You just love being there and just being underneath the starlight.
And
Yes.
I'll put here the homepage if anyone wants to here's the address: explorerscientific.com /pages skies up. Is this not, Scott? Is correct? Is it correct? The link here. I think that it is correct, no, Scott?
It is. Or you can just do explorescientific.com /skies up, all spelled as one word. So, but I've included that as the link, and people can get their issues of the magazine. And if you have ideas for Skies Up magazine, or would like to contribute either images, video, we can even do video, or a nice article, certainly get in touch with us. And I'll give you an email address that you can touch base on Explore Alliance at explorescientific.com. But I'm very excited for Brazil to have their official dark sky park and be recognized for all their hard work.
Oh, we are celebrating. Even it is, we yet are living a pandemic period, but for us was a fantastic announcement for us in this moment. This is the last slide here. We now have the full team that will participate in the project in schools. We shows the team. You have 90 students that will be involved in developing the project and developing. They will develop apps, astronomy projects, and the animations. This is the full team. We have students from fundamental school, high school, and the college students that participate in the team. This we have from 5 different cities near us. All of them are receiving scholarship to work in the project. This is something that we are also very happy about, to know that now we have a team with the students that during our visit in schools, we noticed that they have a great talent, and now they are working with us. This is the final team that will be working in 2022.
That's wonderful. That's wonderful. Marcelo, we should have, we should put in some advertising for the Young Stars of Tomorrow program and the next Skies Up magazine for sure.
Thank you.
And also about the Dark Sky Park in Brazil. And maybe we can have an ongoing series of articles about dark sky parks around the world.
Great. This will be fantastic.
Yeah.
Thank you very much, Scott. Nice to meet
you.
all of you. And I wish to all of you a new year with peace and health. That is the most important moment.
Yes. And Happy New Year, Marcelo. And extend happy holidays to everyone in your programs and your friends and family. Thank you.
Thank you. Thank you.
Thanks. Okay, so we will bring on Maxi Falieres from Argentina. And Maxi, you have been busy with the comet.
Hi everyone. Yes, I really a lot. You know, my fiance says, again, you're going outside to put to get that piece of rock.
Yeah, well, it's once in 80,000 years or something like that. So
yeah, so basically, I present last week, sorry. I did this picture of the comet Leonard that is in my background, and I was really excited because we here in the south, I tell some people that we was very we thought that maybe we couldn't see the comet because we had the experience of the Neowise comet last year, and we say now it's passing through the southern hemisphere and maybe it's going to get more sharpened and then disappear and go anywhere. But it really surprised us because it has 3 outbursts that get more shining, get a really long tail. There's amazing pictures and astrophotography from all around the southern hemisphere, from Australia, Namibia, we're here in Argentina, Brazil, Chile, and New Zealand, and there, this is extremely a really good comet that we are enjoying the view.
Yeah. Comet Leonard has come to avenge you all for not being able to see Neowise.
Exactly. Yeah.
We had our comet, now you have yours.
It's not visible. Well, at first it was kind of visible in dark skies, but I was drinking mate. When we was chatting, Adrian, I sent that picture of taking mate, and then I saw it in my home with my binoculars, and I say to my father, look up, you have to point from Jupiter, then jump to Saturn, and then go up to this star, and you are going to see it. And well, it was really good time. It was outside, hanging out with my family, enjoying the Christmas Eve, and well, let me share my screen so now of what I'm talking about. Share screen. Yeah. Okay. Do you see it?
yes.
Well, you can see there's a lot of dates that when I do astrophotography, I get to get every picture that I do with the date, because it's more organized. It's kind of talk, but I started in the 19th of December, but then I couldn't get until the 22nd of December. Then I get the next day, and also in the Christmas day at the afternoon, and then 2 days ago. This is the picture that I sent to Adrian. Here's the telescope, the camera. It was all together, but also we have the mate, the masitas, some piononos, thermo, and I was really
That is the only way to do astrophotography. It's with the food on hand and all the gear set up and ready to go before it gets dark.
Yeah, it was really hot. for taking mates.
Yeah.
Well, César will know that, but you know, it was a special moment because I was with my family and I was doing what I like. It was really good time. Well, let me. This is a stack of pictures that I did first time of the comet. This was the 19th of December. This is only a stack and out of street the image, because if I go here, this is the stacking. There is nothing, only this kind of that there. But when you auto stretch, you get the info right there. So I was really excited, but I didn't know what was going through, because this was really passing through and really near from us. 3 days later, this is what I get in this time. It really changed a lot. The shape and the brightness that it has, this comet, was amazing. And
That's a beautiful photo.
Thank you. I was really excited because we thought that maybe in the 25th of December, maybe Christmas time, it will going more decreasing the brightness and the magnitude, but it was really the opposite. This was the 23rd. It really changed the shape. Obviously, changed some.
Oh yeah, a lot more defined.
More defined. It has started to have the tail, and if I reset this, the comet, it wasn't like a dot. It's more like a flatter piece of rock, because I think in this time it was having an outburst. Because when when you get this picture, well,
Wow.
I have it here, the edited. It was the 23rd. Well, you can see there's a lot of files. I think is this. This is the.
That's interesting to see the ion tail. You can see that the ion tail is going slightly different direction than the dust tail, and the dust tail is going in the orbit that the comet's going around the sun, but the ion tail is stretching out from the solar wind.
Yeah.
Mm-hmm.
Exactly. And you can see I could get more info here in the core, almost in the coma, but it's more well, you have this kind of helmet it has, and well, the next day this was the 23rd. The 25th of December, it was like this. Well, I uploaded a couple of days ago in my Facebook page. You can see again the shape of the core is really bright when you get stretch. It's changed every single day. I was watching the pictures that 12 hours later take in Australia, and really changed a lot, really a lot. And they're taking this, but what I could get this night here, it was some kind of surprise. So my last one was this. I think this was getting a little more less brighting, and the magnitude is kind of decreasing, but the tail is still observing and capturing. And like I said, this is a really good comet. We think, and the prognostics say that maybe at the 3rd of January is going to get the perihelion, and then it start to decrease the magnitude. But we have too many days ahead, to still watching it, it's going to get more down that where I have the possibility to take here in my home, almost at 9 p.m. at almost 10 p.m. I have it some 25 or 20 degrees above the horizon, and then my home starts to block me. But it's really interesting to what the info that I get. Here, this is an example, you know, this is a single frame, and here's the blink application or tool that does an animation to what I want to show is the movement of the comet that has in almost a half an hour. You know, it's going to be a little fast, or I think it's more late. Was no, it's going to more. Let me see if I can this. Sorry, because the auto stretch. I'm still working on it, how it works this program. Let's see if I put in there. Yeah. I think the software is running now. Let me. Yeah. The stars are aligned, but you can see how the comet is moving. So this wasn't a half an hour only. Maybe in the passing days it will going to get more slower, but this makes you the opportunity to get info, to get pictures, and also
Oh yeah,
if you
this is
haven't,
cool.
thank you. If you having binoculars, you can watch it. Well, if you are in the southern hemisphere, you can watch it with your binoculars almost at the afternoon with the twilight. You know, this day it was amazing to watch it through the clouds and the little shiny stars, and you can see the core of the comet. It was amazing. Also, what I did, I think it was the 22nd. I have my equipment outside, and I said, tomorrow I don't have to work. Yeah, no, so no, I think I have to go to. No, yeah, I have to go to work, but I did some pictures of Orion. I tried to do some. I don't know, a mosaic pictures of different places because I have a square sensor, and it's really get zoom. But this is what I could get because I want to get the Running Man Nebula and another place of star, but this is what I get that night.
Wow, nice.
You know, it was in this part is the Running Man Nebula. I think I have. I didn't. Oh yes, I deleted the picture. Let's see if I get the only frame. 22nd, Orion. Well, I started to the Running Man Nebula. This is only a one side of that place because I want to stack in every place to get the info, but I couldn't. Maybe I still, I never did that kind of picture, but I really like to get it someday. So to get this part in there, and it has the Running Man Nebula and the Orion Nebula with these shining stars. So also what I'm doing, last day I was stacking in. I think I have the DVA picture. I was in this place of galaxy. Sorry, it's M77, I think. This is a really good galaxy. It has this shape of nebulosity that is difficult to watch it, but also we have this place. It's more like the Sombrero galaxy. It's really similar. And also I love when the stars are really like that, really with the spikes. And this tiny galaxy really far away from us. And also there are too many in the background. You know, look at this. This really,
what? Oh wow.
Yeah. It's really far away, that one.
Yes.
But I also try to get to the another comet, the 90P Borelli, but I couldn't get it. I couldn't find it. And also, I think I download this picture. Was the 25? Yeah, here. I did some pictures of that I have to. Sorry. Well, today we were talking with Conal of the Pleiades, so I get pointed my telescope because I want to show to my mother how it looks like with a picture. And I think it was this. No, sorry, this was the Borelli place. It wasn't there. Yeah, here. Here are some places of the Pleiades. I think I missed one star because it doesn't fit on my field of view. But this is the nebulosity that says today Conal, and then also David Eicher correct us or say us that this is not part of these stars. You know, this is a really good place to watch it and also to take pictures. And this was only practicing and try to see what I get that night. So I hope in these next days, maybe I will try to get in dark area. Maybe I will go to Alberti. I don't know yet, and try to do some pictures of the comet with good dark skies, and also having more time to get it, and also enjoy the view and well, support the heat of the summer. Unfortunately. Well, thank you everyone, and I want to say to you a really a happy new year to all of you, and I hope this 22nd year gets more better than that we passed through. So thank you, Scott, and I continue with you.
Thank you very much, Maxi. Thanks. It looks a little windy out there still.
No, I have my turbo, my wind blower because.
Oh, your fan.
My fan, yeah.
It's going. You're outside. You know the wind's blowing you around.
No, it's really hot. It was almost 41 Celsius degrees today. It was really
En mi balcón es peor, Maxi.
It's worse.
No sé por qué se me ocurrió salir.
No, you're crazy, man.
No, totalmente. Porque en la familia, a esta hora todos miran películas y que ellos dicen, no molestamos, vamos al otro cuarto a ver, viste, no, digo, me voy al balcón. Sí, yes. Sorry that I started
No, it's
talking
fine.
Spanish. Yeah,
It's
what
an
are you
international
talking,
star party,
César?
so you can use
yes.
other languages, no problem.
With
Yeah.
Argentinian read of our pronunciation is a nightmare. I know that it's impossible to understand something. But it was amazing the week of the comet. Here I don't have lucky with that because or return at 9 o'clock in the night from the business, putting boxes in the warehouse.
Yes,
in boxes to deliver to another day, and we have a crazy Christmas time.
Sure.
Deliver boxes for our country of that telescope.
So
this telescope. Yeah,
before you get
National
into your program, César, tell us a little bit about Optica Sirocco, and so for people that aren't familiar with it.
Sorry, Scott, I could understood the.
Yeah. Tell us about your shop, your store.
Yes.
Thank you. Yes.
Yes. No. Yes. I mixed some words and
I'm sorry.
No, Scott, your pronunciation is very good. No, that my pronunciation because you're an American.
Oh.
And but yes, our business is from 1954. My father-in-law founded Optica Sirocco, especially for contact lenses and glasses, of course. And he from the beginning of the business, he started to sell telescopes, but a few quantities in the window. Maybe you can imagine Bausch Lomb telescopes, some old Tasco or another brands from Japan in the 60s, 70s, 80s. But in the 1992, I'm entry to the business. I am next year. I'll be 30 years in the company.
Yeah.
In the family company. My wife is Sirocco too. I need to say that we are really yes. And my idea, I was very interested in my teenager time, going to take lessons to La Plata Astronomy Observatory, but only for me, because it was a teenager and optics student. We could study in the night. In the day, we went with another classmates more. We went to learn about optics, to figure out optics for and my experience in my teenager time was very great to start to take the department of telescopes in Sirocco. Well, we started in August of 1992 with this area, and we are going to get our anniversary of 30 years next year. We have a showroom, we have a laboratory for repairing, cleaning optics, and well, a lot of different things. It's very interesting. Tonight, it's cloudy, but I could take a picture with a cell phone with adapter, because I was, that you know me, that I like to try all telescope that we sell. Of course, for every stock, we take 1, 2, or 3 to our staff to show to the people, to show in the showroom, and to use in the store parties. Tonight was the first time that I could use the Explore Scientific series, but the brand is National Geographic, but it's an Explore Scientific. Was very interesting because I was looking really for many years to have a real 500 millimeters focus telescope without Barlow lenses inside the optical axis. When you have a real 500 millimeters, you have a F number very short, and this is very nice because you have a wide field that is great for the kids, because the kids, when other people, their parents too, they lost the mind thinking something that is really shaking, and when you can use the wide angle eyepiece like that, this is plus 26 millimeters, you have a huge wide field because you have only 500 millimeters focus, and you have a 26 millimeters, that is only 19 millimeters, magnification. That is a little more than binocular but with a huge luminosity. And well, I enjoyed tonight despite the clouds, and something that is an open cluster. You know how is my sky from here, from my balcony, but I can show you a picture in the early Maxi Falieres style with a cell phone. You know Maxi?
Yeah, sorry, I was eating.
Yes, I can see. No, sorry. Okay. A masita, una masita.
Vamos, porteño dice masita, vamos.
Let me show you. Let me share a screen. And here. You can see the screen?
Yeah.
Okay. Well, this is a couple of pictures, and it's fun because I don't have an idea what open cluster is. This is of course in reverse, because here it is really it's down, it's in reverse. Here I can make a small change with the most interesting is not the picture, if not is what is who is the cluster, the open cluster. It's in the Vela area, and I don't know if it's a cluster or it's a mix between an asterism. Here you can see 2 stars more. Let me show you. You can see the stellarium, or I need to change the screen?
No, we can see.
Okay. I have an idea. Tomorrow, more clearly, I'll finding who is exactly the cluster. But I think that I'm not sure because it's found when you don't use go to. I am totally lost with that. But I think that this may be an asterism only because this was maybe guitar cúmulo or maybe in this area cúmulo del velocista. I don't know the name in English. But show something like more stars. And I can see the red star in Carina because I know that the star and it's really huge, and I think that it's not this is in this area really, but the fun fact is that I couldn't see which cluster is. It's an open cluster, but maybe sometimes you have a cluster mixed with some asterism, and well, it's a nightmare to understand which is the cluster. But I of course that I had really an fun time taking pictures with the cell phone. That is really great in middle of the city. Another thing that we have problems in the city, and really we need to put the distance between the eyepiece and the cell phone camera lenses in the eye relief that is the best place, because if not, if you are in the Maxi Falieres sky, for example in Alberti, you don't have problem because the parasite light is really so low that you don't have problem with this. But here, where you have a very short focal distance and a long focal distance in your eyepiece, your eye release is critical, and you have a lot of light that is if you are not in the right center and in the distance between the eyepiece and the camera, you have a lot of different kind of light that is impossible to get a clear image with how do you say, with the completely something that is the same in all areas of the picture, the quantity of bright. And this is the only thing that is more easy with the shorter focus ocular to take pictures, and especially take pictures of the moon and planets. But I could take pictures of an open cluster with the regular mount. I can use the EXUS 100 tonight, but I'll use and I'll try the telescope with the go-to mount, maybe, I don't know, tomorrow or when the clear skies returning. But this is a great way to have fun, and thinking that many kids received this for Christmas. It's really nice, and it's for the people to have fun, especially for kids. it's a really a great combination between short focus, wide angle eyepiece. Well, you know, it is all. Is really special for Maxi that Maxi have make an excellent pictures with the cell phone. Returning to your past, Maxi.
Yeah, I I was remember that time, and when I see my graph now, I say, oh, I pass a lot in these years, but sometimes it's good to go back again and and still get practice. And
yeah,
I still having the same phone that start help me start in this hobby, and now it's more like kind of type of professionally, but it's good to sometimes goes back. And
yes, I have the temptation to send you one.
yeah, if you
Yes.
want.
No
my wife
problem.
will not be really.
Yes,
really
only the no problem. Only the OTA, and you
yes.
say and send to Maxi to try. You agree, Scott?
Yes.
Yes, in hands of Maxi, what is possible to make with this telescope? And with a cell phone only, of course, it's impossible
Yes,
to make
I
with a
will
reflex
try.
camera.
Of course, with maybe M42, how is see it, how is the field of view, maybe it's with a really good eyepiece, like 25 millimeters, or the 32 is it has more
Yeah.
field of view, but the 32 has a more coma.
No,
and
yes, and you need an eye
relief.
an eye relief to yes to separate, and
Yeah,
you
but
know,
also you
and
have
this is no it's for a kid telescope, and you don't have
Yeah.
here yes the high grade Explorer scientific telescope. If you need that, of course that I can send you that. You can pay that, but no, the idea is yes, no micro focusing. No. This is only. But work very well, Scott. And the first something that is great, and it's when you see the telescope, especially in our business, when we choose a telescope to sell, we every time we really are with the expectative of to say what kind of telescope, because I saw the videos of Levy in the stars, making the unboxing, or Scott, or I found a old one video with Kent. Now I have one in my hands, and I can see too that is a great telescope to an starting excellent telescope. Many times in the past we have the starting telescope with only 60 millimeter or 50 millimeters, and you can see nothing. Here tonight, maybe half hour before I started in the Zoom tonight, I take pictures with my cell phone. Of course, that there are no because the problem of the light pollution and the cloudy nights, you have a lot of illumination inside the picture, but you have an open cluster, and you can have a word for a kid, for example. You say, okay, I have this. What cluster is this? I feel the same. I have for a kid, it's not only for a kid, for a teenager that are interested in astronomy, is I have the picture of an open cluster, and I make the same question. What cluster is? And this is great because you need to put in reverse and you need to start to show, to, to, to see the picture, comparing with the star maps, going to a book to see if it's an asterism or it's a real open cluster. Because do you have an idea where is in the sky? Do you have a compass inside the Altazimuth Mount? And I have an idea where is the area of the sky where you found this. But the interesting thing is you don't need first of all, you don't need for a star a equatorial mount. This is something that is irrelevant. You need only take the idea where is in the sky the things that you are watching, because this was in reverse. This is okay. I can see an amount of stars in an area of the sky. If I see to this area with my naked eyes, I can see anything. This is the idea. First of all, the real power of a telescope. It's not magnification. That's
right.
Light. It's the capacity to get light. And I tried, if I can put an amount of stars in the field of the eyepiece and take a picture and have something like like a register or something that you say like in a small observatory, you have something. And this is an starting really good comparing with a telescope where they're really small. You have your first telescope, and I remember in my childhood the telescope was maybe 40 millimeters of diameter. Today, it's for, if you think that for kids you can have f4.30 number, you have a very fast telescope. You can put a cell phone and show more stars, maybe like a naked eyes. Come on, do you have an starter telescope that it's really is much more that you can imagine in few years ago. The optics of this, something that is important, that is not an spheric mirror. They have a huge work making a very huge difference between the sphere and the parabola. And for an industrial telescope, thinking for kids, it's amazing that the industry say, okay, we can do it very good, because I have a Foucault test. I put in the Foucault test, and really was I couldn't put the the Coudet diaphragm for to see to take the measure of the parabola, but the difference between delta and delta, we call it delta P prima, the difference in the spheric aberration was really short, talking about a great quality of optics. I'm thinking for again, for a telescope that we are thinking to sell in a Walmart for Christmas, and you have something that is beautiful in optics.
That's right.
This is really the how was improving the industry in these 30 years. When I thinking that I sell from 30 years telescopes, come on, this was so impressive for me in the last 30 years. how the things changed. And despite the go-to mounts and an amount of technology that incoming, but this one that is for kids, and this is the Christmas telescope, is amazing and work really in a very good way.
Yes.
It's
well, you know,
the time of the Webb telescope.
Right.
Yes.
It's amazing. It's amazing what we're going to see with a huge telescope in space, but it's also amazing what you can see with a small telescope from your patio or your backyard. You know, so you know, telescopes just peel away the onion skin, you know, to let you see, to probe deeper and deeper in the universe. But overall, when we apply our mind to this exploration and what we've learned, you know, it doesn't stop at just what you see. It doesn't stop what you see. You start to make the connections of how we are related to the stars, how we are connected to the universe. You start to learn, you know, you see a conjunction with Venus and the moon or something, or you see an eclipse, and you start to understand that we're in this dance of our solar system, you know, and things are moving, and it's all dynamic. And as Dave Eicher pointed out before early in the program, he talked about, you know, how amazing it is that that we as living beings that have learned how to look at the sky and try to make sense out of it, make the tools that we make. You know, it's just we're just so fortunate, so lucky. So you know, and I think that most astronomers understand that. That is kind of the message of the theme of the star party this week, which was the life of stars. You know, it is, they are amazing. It is where a process of creation is taking place. And, you know, it's when we look at beautiful things like the minerals, or we look at planets or exoplanets or other stars, explosions that happen in the universe, the beautiful nebula, all these things, you know, it all starts, much of it starts with the stars itself, you know. So I hope that with James Webb Space Telescope, that we can see some of the very earliest stars, the formation of stars perhaps in our universe. And you know, it's gonna start to put together the pieces of the puzzle that is missing for a lot of physicists and you know, the cosmologists and theorists. So
absolutely, Scott.
Yeah.
Yes, it's incredible. And how in the media, it's every time is have more in the popular media, in the popular culture, starting to have more space. Well, the space really is the word. The astronomy. In the last successful movie of Netflix, the Don't Look Up, the history is about, of course, politics, and you know, the politics shows, but the idea started with the astronomy. When they are the astronomers, they are making the same that amateur astronomer we are watching in the screen, watching if something move different. Hope because they found the comet, and
yes,
this is well, we have a lot of fun with this movie last week and with my family. And really, despite the politic jokes that is in the same countries, this in my country is the same. We have yeah, the same idea, the middle time elections, and you know, but despite this, the idea of for the people to pay attention, and the people how fighting with idea, the media fight with the scientists and the politics, and it's the same kind. And it's so important to have to give education, astronomy education to the kids. And we are really happy that we saw a lot of telescopes for kids, where is a choosing of their parents, when the kids can be amazed with the sky, but the choose to make this gift is from their parents. I'm really happy. I have my hope in humanity is restored again.
Yes.
Yeah, no, but it's real. And they said, with the parents came to the store and say, look, we have our kids that he have 12 years old, and he's really interesting. Sometimes is younger. Sometimes yes, my daughter have 7 years old, and sometimes sometimes I say, okay, I don't know if a telescope is the best option, but when I talk with their parents and I say, okay, if you make the history around the telescope, and you take the telescope and go to your backyard with a daughter or your son, and make the experience, and I can help you to make this experience, you have this kid maybe now 7 years old. Sometimes watch the moon, watch a planet, maybe Orion Nebula, that it's more easy to understand in the sky. But this kid going to their first years of their own teenager time, when he go or she go to be a teenager,
yeah,
carry their own telescope. The first night that carry their own telescope, and she or he use by first time only the telescope without their parents, the magic starts. And it's the same that, okay, I took the picture of this group of stars, and come on, which one is? I need to see in a map. I need to ask to my teacher. I don't know, but my own curiosity started, and this is the magic. It's really the first day, the first night that you put your feet in the first step of astronomy, of your astronomy, amateur or maybe a career in the future. I don't know. I know professional astronomers that received a telescope that bought in our store many years ago, maybe 10, 20 years ago. I know professional astronomers, actually, doctorate, that received by their parents a telescope 20 years ago. This is it's great, really great.
That's right. That's right. Yeah, you never know where a small telescope can take someone, so it's
absolutely
most professional astronomers that do like to get their hands on the equipment. There are some professional astronomers who just look at data, they just do math, that this kind of thing. But it is, I have met many professional researchers who also say that they are amateur astronomers too, because they love the sky. So, and they love to do backyard astronomy as well. So,
yeah,
it's it's important that you just apply the telescope and try to get the best performance that you can out of it. César, you are absolutely one of those people that do that. Maxi's another one. Nico is another one, so I love I love what you guys do, and it is inspiring because many people think that you really do need to have huge telescopes or spend lots and lots and lots of money, to the point where it's almost unobtainable, and so some people don't get involved because they think it's unattainable, but you can do some wonderful work and make many personal discoveries with very modest equipment. So
Yeah, absolutely, absolutely. Today, how Maxi managed the pictures of the comet and a lot of things that Nico show how well the picture of the comet that took Nico is amazing too. And it's really a great time. Something that returning with this kind of telescope without cameras, only with cell phones, and this is something that is so important because the technology can be affordable something now that was impossible in the past. This is technology too, because not all, well, the cell phone is amazing. It's impossible to. When we was kids, we thought, maybe you too, Scott, that the cars in this time, we thought that the cars in 2022 are flying only, not no more cars in the ground. Yeah,
I remember.
But
as children,
never,
we thought this.
absolutely,
for
for me was yes. So back to the future, the movie, they all say, okay, no, it's, but this technology was impossible to imagine. This technology was impossible. If you return to the past and show this, it's more amazing.
Their minds would have been blown.
More mind blowing, and this. First of all, a telescope in the 80s only. To if you see, okay, carbon fiber, two with a very full. I remember that never in the 90s I could afford a telescope under number 7 F, because it was very complicated to make a parabola.
Sure.
Yes, here have a physics parabola and a high vacuum aluminum parabola too, and they make a perfect shape.
Yeah,
this is technology, and this is maybe so complicated to make an industrial grade, like make this, because it's the same. It is another way, but when you put this here and make this magic, come on. It's simple, works, and for me, it's more important that another things that I sell, like guider, guider cameras, or all the stuff that the people love. But for me, this year, after maybe 3 or 4 years that we don't be able to have a stock in Christmas to sell telescope, starting at level telescope, was I have really an enthusiasm that really this year I remember again, they say, come on, I love to sell starter level telescope. It's because if
it's where all begins.
Absolutely, Maxi, absolutely, because with all my in the last 3 years, maybe I couldn't get a huge number, because maybe I don't know why, because maybe I choose a high level, middle and high end level telescopes from the another companies. Well, with the pandemic situation, it was impossible last year, but my connection with parents that say, okay, I need to I need to make a gift for my kids. I say, come on, I'm returning again for something that it's really really amazing, because they ask the questions that you receive are different, and they say, come on, I can see the Jupiter, and I say, yes. I can watch that. I don't know. Well, this is something that I really appreciate a lot. It's great. Was great. These days, I I'm, I was making giving support, but very you know the starting support to say, okay, this is something that yes, this is Venus. It's not the moon. Okay.
You
I
know,
love that.
a couple days ago, I get a friend request from a person from here from Chivilcoy, and he wrote me in Messenger and asked me if I can help to I don't know if it was him or her, to how to use the new telescope that they bought to their daughter, because they thought that maybe it's uncollimated, or how it works. It's only azimuthal mount, a 76 reflector, but I say I have no problem. Let me what you want to learn. What are you asking? Then I say, tell me if I think the better is if I go to there to explain you how some kind it works, and how to use it, and some know a little bit of the sky nights, but they didn't tell me come here to my home, or because they want to bring me their telescope to I explain how it works. I think it's better if I go there, because the is if is it collimated, it's better is in there first of all, and also you are using your house. That is where you're going to use it.
That's where you're going to use it. That's right. That's a good point.
Exactly. So if you see how I see the sky here, that's okay. I have almost the entire sky, but maybe I don't know if you have a building. I don't know if you have a tree or a little patio. Exactly. Exactly. So, well, I don't. I'm open to that kind of question. Even I didn't sell that telescope. I didn't know that person. I think this person asked in a group, a Facebook group here in Chirigoy, where people sell things or know, ask for if know something, that if someone know how to use a telescope here in Chirigoy. Some people tags Armando Sandanel, of course, the director of the Southern Sky Park. And also a friend that has a couple of years ago text me, and then they text me, but you know, I really enjoy how I was explaining with voice to get. I don't know if could understand me, because I try to not be really technical. But because sometimes it's very difficult in that case, and also I'm not very technician sometimes, but I like to explain, and I feel really grateful because they have that tool, they have that telescope, they don't know how to use it, but today they can find a way to how to use it. When I was a child, it was very, really, really strange here in Chile, go in a farm city, a telescope. What is that? You know, only they knew glasses. That's all. And today is well, with the internet, with the connections, it's more easy to 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 make a or to make they know of uh, how to use it
Yeah, the awareness of how to use it.
Yeah.
So it's really wonderful, Maxi and César, that people like you will take the time to teach other people the sky, how to use their telescope to find things in the sky, you know, to understand some of the culture of astronomy. And, you know, I mean, when you think about all the things that you did learn, all of the things that you did know, and all the wonderful people that helped you, you are carrying on a great tradition of, you know, passing on the knowledge, you know.
Yeah.
Now,
That's the
yes,
point.
it's expensive for any of us to pack up our car and drive a long distance to go show somebody how to use their telescope. I've done it. You know, most amateur astronomers do it. I think we do it because there's some responsibility, because somebody did it for us. So, you know, there was a movie called Pay It Forward, okay, where somebody would do something before they got something. You know, they would just like, I don't know who you are, but I'm going to help you anyways. And they're paying it forward. And astronomers do that a lot. You know, they help people they don't know. They share experiences and you know, lots of knowledge to them. And even though, Maxi, you say you're not a technician, what you do know is really amazing, you know, and you can enable people to understand the sky in ways that they never thought would be possible, you know. And it starts, I mean, César, you know this, and Maxi, you know this, by showing people a planet for the first time. Tarek in the United Arab Emirates, he says, you really have no idea how my friends and even kids visited me and looked through telescopes. They were so happy when they looked through the images in the magazine, than the images that they saw in magazines or, you know, Hubble Space Telescope images on the internet. He says nothing beats live by eyes or seeing the images done by an amateur astronomer, you know.
Feel that photons through your eyes and get to the retina.
That travel. Yes.
To the
From
eyes
time
sensor.
of the dinosaurs. Yeah.
To get processed by your brain and see, oh no, you're looking to a planet, to another place, to another body celestial.
Something. Yes, you're right, Maxi, because something that I felt tonight, because I started to see, okay, in between the clouds, I needed to put something in the line of my telescope, and when I found the cluster, I felt again this magic that you talk about. The come on, wow, stars, and a lot of stars. Was not a global cluster or a nebula, only a open cluster or maybe an asterism. But you know, was the magic again? I forget a lot to put my eyes in the eyepiece. Of course, that after I put the
cell phone, I say, oh no, I have to take a picture. Yeah.
No, yes, because it was the idea of tonight. But first of all, was funny because I used a part of the wielding that I have to align the idea to where I can search something, and with my eyes, with a telescope. And this is really great. I appreciate to use again the you know, the telescope to watch and enjoy it again. I show in the 2 weeks ago the store party, not not the store party, but the books night in San Miguel, where we put a couple of this telescope for the kids watching the moon. Was a great experience, because when you see the kids and say, because sometimes the fun thing is that they, like me, if I don't use a telescope, it's maybe, if especially with this kind of short focus and wide angle eyepiece, that if you are not in the center of the eyepiece, you can see nothing.
Yeah.
And the people say, you can see, the parents say to the kid, and the kid say, and you first of all, when the kid is in the axis, they receive the light of the moon in the eyes.
Yeah.
But the most important is the expression.
Exactly. Yeah. When they do
Yeah.
really see.
Yeah.
That's
Yes.
Instant crush.
Yes, absolutely.
Instant moon crush. Yeah.
Yeah. Yes. Absolutely. And
know,
this is something that
maybe some astronomer, if they're watching, is going to kill me, but because I love to do astrophotography, but I really forget to watch the comet through a telescope. For example, I only did with the Maxi when I was taking pictures, because I put another grab, and I find it, but it was really for the diameter of the telescope and the focal length. It wasn't really brightening, but I have to try with the 8 inches f4 to watch it and take that night to only watch it, not take a picture, only reserved for me the experience. I think, but I really forgot it.
Yeah.
Yeah, I
And it's a
decided
shame.
I decided to jump in at the very end just to I figured out a problem with my other webcam. The cable was bad. And then two, just to listen in live to the excellent talk about outreach. I am going to be heading to bed here as I finish dinner, but I in agreement with everything. And there is one issue I've run into when I've done outreach, is because of all the beautiful images that we've taken in astrophotography and things that are available online, sometimes folks will expect to see that through the telescope, and we have to inform them that no, I'm sorry, the Hubbell image isn't what you see. This is actual light coming directly from that object into your eyes.
Yeah, absolutely.
And you sort of have to level set, because they can't see it. They're expecting this big, bright, colorful thing, when in reality all they'll see maybe is a little hint of what the object is. Now, if you're using different filters, that object shows up.
Sometimes when the people look through the telescope, for example, to watch the most M42 nebula, they even don't know how to get a shape. They see the stars, but you ask them, do you see the nebulosity? Do you see the stars in the center? And they say, no, I don't know.
En castellano, please. No sé. Vamos a comer un asado. No sé.
I'll tell you what, I had a sky glow filter in. I had seen, the beginnings of M42, 43. I remember putting in the sky glow filter with an 8-inch, and I pointed it at the Orion Nebula, and then I had to go back like, whoa. And I just remember that being, because of the filter being in place, I saw more of the wingtips and all the the dust lanes and all the things that you can see. And this was in my neighborhood.
In that case, what I do,
it did help.
is show them later. They see through a telescope. I show you a picture of M42, and I say, okay, what you saw is this, and then they remember something that they
Oh yeah, I
see.
saw some of
I
that
saw they okay,
wingtip.
and then they go
Yeah.
again, and in that case they start to get that shape, and
Yes,
it get more clear, and say,
that's
oh
right.
man,
That does help.
Yeah,
yeah,
You
yes,
describe
it's
what it is. Yeah, it's someone unfamiliar with it. It's like I'm not sure what I'm supposed to be looking for. So unless it's just absolutely, blows their mind, then
yeah.
they're like,
You know,
"Am I looking at the right thing?" Well, it's this. Yeah,
a
you
couple of
were.
days
yes. There,
ago,
You just
there's
have to process it.
a couple of
the
days ago, I was
expectation.
watching the movie, of course, of Marvel Comics, Endgame, and when the movie starts, you see Tony Stark in the middle of the space, in the middle of nowhere, in that spaceship, and the background, it was M42. I say, man,
That's
M42.
They could have used one of your
Yes,
pictures for the
yes,
background.
Yeah,
yeah,
and
yes, absolutely.
and then you start to, of course, they took a picture of maybe everywhere and put it there and get the shape, the colors. It was amazing. It was, it was floating in the middle of nowhere, but it was the M42 right there. I don't know, it was another one. I couldn't recognize it, but it was shocking in that case. When I saw it, and I saw something, maybe invited something, or but when I saw it again, oh man, boludo.
What I would emphasize most in those outreach projects is, like you said, they see a movie and there's Tony Stark in front of this huge, beautiful M42.
Yeah.
And while there are some beautiful images and paintings out there of some objects in space, what I think is really important in outreach is to say, here's what you are looking at. Not just the name, not just the title, but here's what's going on here.
Oh, yeah,
M42,
yeah.
it's a stellar
Yeah.
nursery. There's stars forming. If you
That's
look
right.
at M87 in Virgo, it's just a white blob in most telescopes, but that's where they photographed that first black hole a year or two ago. So I think
Right.
that really drives home a lot of the points we want to make to the public.
Yeah.
And how,
Interpreting
yes,
the
Conal.
sky as much as you can and the processes as much as you can is very important. But also to, and if we're going to talk about outreach, I think it's very, very important that you don't talk down to people. If you know something, if you know more about the subject than they do, you don't try to talk down, and some people, they do get, they're very proud of their knowledge and they really want to share that, in a
Yes.
way that, that comes off like, hey, I'm a little bit smarter than you are. Okay. And
Yeah.
that is
Very good point, Scott.
unfortunately a turnoff for people that are getting into this. But if it's people like yourselves, wow, that's a treasure, because you start to open up the whole universe to them, and you can see them starting to take those steps to start exploring and learning, and that is really, really important.
Yeah, especially the kids. It's amazing
Yes.
that they are interested. And sometimes something that we talk about the nebulas, on how the people sometimes see their first nebulas. Of course, that we talk many times in the Global Star Party about when what kind of object do you show to your neighbors or people. It's not the same for everyone, of course, that it's the moon, but if you don't have the moon in the sky and you have you are the guest and you have visits in your home, okay, choose the Orion Nebula here in summer. But I think that, like Maxi, that you need to show you something like a picture, to have the idea, to prepare the people to the show. Because if not, they say, okay, I remember I remember that we we was for a special party. We were contracted for a special business party in a palace. Very. We went to many telescopes. We carry an 11 inches telescope to this party of all rich people, and you know, what's the people and drunk people especially, and the people say, "Come on, what's the same? What's the same? If you show a picture or a nebula, or I say, okay, no problem." The kids, the kids, no, sorry, my assistants, the people that come in with me to the party, to the event, they told me really worried. Come on, the people don't understand nothing, and come on, no problem, don't worry. These people is drunk now, they are fun, and sorry that Maxi is lost, but for example, something that is one of the name of the old channels of the XXX TV, the name is Venus. And I remember that we are showing Venus in the sky, very beautiful Venus, you know, like now with a very big, with a finest, how do you say, like the moon. When the Venus is, it's very
thin,
very
crescent.
thin. Yes.
Yeah.
Okay.
And the people say, "Oh, Venus, ha ha ha!" They make the joke about the channel of XXX porn movies. I don't know, Maxi, if you if you listen the last.
No,
just
sorry,
came back
I have,
on.
yeah.
Yeah, and
that's
all.
it's
And
the
the
probably
worst part is at every minute, some people imagine the same joke and make the same, and we say, ha ha ha, okay. Maxi, about the Venus, the channel for porn TV, and all people in a party, in a special event, we are showing people all through 11 inches Schmidt-Cassian telescope, you know, and all people make the same joke. It's the same. I can imagine if you point to Uranus, it's horrible.
Yeah.
Okay.
Uranus.
No, yeah.
It's. I make it a point to.
Drunk adults often can ruin the event.
No,
that can be. Yeah, the way to handle it is acknowledge what they're seeing, and give the other explanation. Say, yeah, we realize that that's what you're seeing. Isn't it amazing that you can imagine these things in space, because it really is up to what your mind is. I remember the last star party, the planet Uranus was one of the planets that we were able to show. So everyone comes up with the jokes about
it's
the
impossible to
pronunciation.
stop. Yeah.
And so one of the things that I read in an article is that that can pose a real problem for funding for scientists to send a space probe out, because here we go with our perverted mindsets. We would like to send a probe to Uranus. We'd like to send a space probe to Uranus, and then somebody repeats, wait, let me get this straight. You want to send a probe to Uranus? And then everyone starts giggling.
Yes, and
space is one of those. It's one of those things that
you can't win. I'm sorry.
Yeah, you can't win. No. And the bad part is, you want to visit what's called an ice giant. You have to say, well, we're going to send one to Neptune. The joke isn't there because Neptune doesn't evoke any joking. So real science that you want to do at Uranus.
Sure, and you have the attention for the kids. And you you made the joke, okay, and you first of all, they wake up in the class because maybe it's the 40. I think that is third degree, the first time that they really make the joke. third in Argentina. I think that, but in Argentina it's impossible because the Urano in Spanish is unable to make a joke. In English, it's perfect. It's
Yes, but
Yeah.
your is because of you, or
yeah, no,
here in
yes,
Argentina it's not like that, because
no,
you is
Urano,
vos or tú. It doesn't the
maybe
same.
the
So
Finnish, but
yeah,
but I remember in Cosmos when the first time that Carl Sagan started to talk about Uranus, they talk the famous planet that was the shock of every third degree kid, because it's a tradition. But every year that the teacher that start to talk and the kids laugh because it's something to wake up, to start to talk, and it's great. It's not bad. Many people say no, okay.
Maybe to avoid that kind of joke, you can pronunciate in some kind of Latin word, or maybe in Spanish, but
think the
do it
Dutch
the
use
pronunciation, because
Uranus.
Urano.
Yeah, Urano.
Urano.
I think.
This is the planet
Maybe,
Urano.
maybe, yes, but maybe we pronounce
Or
Latin.
call it Planet
I don't know.
George, like it originally was. I think it was originally Planet George.
Yeah.
And
That's
then
true.
it got renamed because other planets celebrated, I think, the Greek gods like Jupiter, Saturn, and then the moons all got named after Roman characters, or Roman mythology. And then there's Planet George. And of course Planet Earth doesn't have its its name. It stays Planet Earth. And so it got changed from George to Uranus, and then over history it's Uranus, Uranus, and Uranus.
Yeah.
And I've the
gets
names
twisted.
are there, the science is
No,
but the
yeah.
science that's
We're
done around it
devolving
is real.
into this thing
Naming
that
convention.
anyways, but what it does all of this does remind me of too is a book, a star map, a book of star maps by Johann Bayer, and it's called Uranometria. And beautiful, it was a beautiful book.
Uranometria,
with incredible drawings, classical drawings of the constellations and the mythological figures and all the rest of it. So if you haven't had a chance to see a Uranometria, well, I'm going to put a link to it so you can see some of the pages and stuff. But I went to an antique bookstore in Los Angeles one time, and I just asked him, "Do you have any antique star maps?" And I had just read about the Uranometria. I would never believe that I could actually hold one in my hands and see one. Okay, but he says, "Yeah, I got this one," and I open it up and I start looking through the pages, and it's got writing in it by Johann Bayer. Okay. And so this is about 1989, something like that. He wanted $2,000 for the book. If I'd had the money, I would have bought it. I don't know.
Yeah, wait, let me look in my pocket. Oh, there, look, I got $2,000.
Charge up my credit card.
Yeah, that's just charge.
If we
it up.
pooled as GSP, we could probably get it.
Yeah, we'll do a GoFundMe.
Yeah.
Right.
Oh,
This is something that we know now, the gift that Scott need.
Yeah. We'll be ready for next Christmas.
Yeah.
That's right.
All of you still watching, we're gonna build a GoFundMe page. We're gonna get this book for Scott.
Yeah. Actually, a book like that belongs in a museum. It really does.
Sure.
So.
Yeah.
Mm-hmm. Someday I will take this book and donate it to a museum. And this book is, I've shown this before, but this is the Astrophysical Journal from 1916.
Wow.
Okay.
Wow.
So and this is the journals were not hardbound like this one. The guy that hardbound this was George Ellery Hale, and he did it for his private library. Okay, so this is a book from George Ellery Hale's private library. And if you look inside, it has some stamps on it. This says the Astrophysics Library. That says from the Palomar 200-inch dome. And there is a little stamp that says George E. Hale on it. And the second set, so he kept 2 sets. And then on this page is George Ellery Hale's signature in pencil.
Intense.
Yeah.
Really intense.
That's
My
incredible.
God.
This is
My God.
over 100 years
Well,
old,
that-
but it's a collection of articles and stuff about astronomy, you know.
Yeah.
Yeah, that goes into
Really
the
cool.
safe. Yeah, that goes into the safe. I'm surprised showing the signature just didn't wipe it out somehow.
Exactly.
The light just bleached it out.
Yeah.
But yeah, that's definitely that is a very important document. I see it's going back into the dark chasm with which it can be preserved.
I have a glass plate taken on the 100-inch telescope of the moon from Mount Wilson, and that's over 100 years old. So it's these things are being thrown away. Both of those items were thrown in the trash.
Oh,
Wow.
man.
Yeah.
And
So-
you preserve.
Yeah,
how much?
I
You know,
didn't
how
preserve them. Friends of mine
more-
did, and they said,
Okay.
"Do you want one of these?"
Yeah.
Yeah.
It's like, you bet I want them. I know the Vatican Observatory has a lot of
But I'm taking care of
they
them
kept.
until such time that I can get them to a place that won't throw them away, you know?
Yeah.
So that's the deal.
No.
But
Good point.
yes.
All
Well, I
right.
really think
All right. Yep, gentlemen, I'm going to disappear for real.
Yeah.
It's always wonderful Tuesday night star parties, or if they happen on another day, then that just means whatever bowling that I might have wanted to do just got canceled. Star party is more important to me.
Yeah.
I've enjoyed being on and sharing images and hanging out with the Argentinian contingent, as it were. And Conal, welcome to Team Argentina.
Yeah.
They shut down
Thank
the
you.
star party usually,
No.
and this is where we
It's
have
a
the most
honor.
fun and have
It's
the
a
deepest
honor for
discussions.
us.
Yeah,
it's a honor.
it's most
Yeah,
philosophical, but
Yeah,
really, really
we had a
good.
lot
Very
of
good.
good discussions. So,
Well,
so I
you have a
will
great
bid everybody
week.
adieu.
Yeah. Happy New Year
Yes.
to all of you, you know.
Yeah.
You know, have a
You too.
safe Happy New Year weekend, and we'll be back next Tuesday with another Global Star Party, number 79.
Yeah.
Yeah. See you
Numbers
next
keep
year.
getting bigger, Scott.
See
Fantastic.
you
Yeah.
next year, people.
All right. Good night,
Have a good
everyone.
rain.
Thanks.
Good night,
Good night.
everyone.
Good
Night.
Bye.
night.
COVID-19 vaccines are safe and effective at protecting you from COVID-19, especially severe illness and death. Vaccinated people are far less likely to be hospitalized or die because of COVID-19, including the Delta variant. COVID-19 has a much harder time spreading in a vaccinated population. When more people are vaccinated, we are all better protected against COVID-19. Even if you're young and healthy, it's still important to get vaccinated. Vaccines can help end this pandemic. To get the most protection, make sure you get all recommended doses of a COVID-19 vaccine. Getting vaccinated helps protect you and others from COVID-19.